Maaf ya Mas, maaf lagi. Iya ya. Kapan sore ya, Bu? Iya, rahasia. Kalau dia harus salaman kan? Lagi kita keramaian cerita ya.
Nggak yang paling terakhir. Sudah ada temannya.
Oh, katanya boleh nama jasa. Oh, yang CD itu yang setelah diprogram di base itu kan dia megang soalnya nggak tahu ini gimana P2M
Selamat pagi Ibu Bapak. Hadirin yang kami hormati, sebelum acara dimulai, izinkan kami membacakan pedoman keamanan, kesehatan, keselamatan kerja, dan lingkungan di ITB. Pada setiap acara kegiatan di ITB, termasuk pada acara ini, kami dari Keamanan, Kesehatan, Keselamatan Kerja, dan Lingkungan berkewajiban untuk menyampaikan pedoman keamanan dan K3 yang berlaku di lingkungan kampus. Dimohon untuk menjaga kebersihan gedung dan membuang sampah pada tempat yang telah disediakan. Demi keamanan, dihimbau untuk tidak meninggalkan barang tanpa pengawasan, tidak diperkenankan merokok di dalam gedung ini dan kawasan kampus ITB kecuali di area merokok. Pastikan puntung rokok mati pada saat membuangnya ke tempat sampah. Hadirin dimohon untuk memperhatikan letak pintu darurat pada ruangan ini. Pintu darurat terletak di atas ya, hanya ada satu. Baik, dan berkumpul mengikuti jalur evakuasi di assembly point dengan bimbingan satpam. Dalam keadaan darurat atau jika ada yang mencurigakan, silakan menghubungi petugas keamanan terdekat. Demikian pedoman ini disampaikan dan kami ucapkan terima kasih atas perhatian dan kerjasamanya. Kami mohon kepada Bapak Ibu yang ada di ruangan ini untuk selalu menggunakan masker, menjaga jarak aman, dan memastikan telepon genggam Anda dalam keadaan silent. Boleh dicek ya, HP-nya harus dalam keadaan silent. Distinguished guests, ladies and gentlemen, may we have your attention, please. Good morning and welcome to the grand ceremony and seminar on research findings assisted by the Asahi Glass Foundation 2022. On this fine occasion, I would like to welcome our distinguished guest, Senior Executive Director of Asahi Glass Foundation, Mr. Hiroyuki Watanabe, Director of Asahi Glass Foundation, Mr. Shin Tatematsu, the Executive Secretary for Research of LPPM ITB, Dr. Rino Rahmatamukti, and all ITB officials. There are 3 sessions for today's seminar. The first and the third would be the presentations by researchers and research grantees. The session in between would be the opening ceremony. Ladies and gentlemen, to begin with, I would like to invite the Executive Secretary for Research of LPPM ITB. He will give the opening address. Ladies and gentlemen, please welcome Dr. Rino Rahmatamukti.
Good morning, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. So, distinguished guest, Mr. Hiroyuki Watanabe, welcome. Senior Executive Director of Asahi Glass Foundation. Mr. Shin Tatematsu, welcome to Bandung, ITB. He is the Director of Asahi Glass Foundation. So, ITB fellow, students, good morning. So this year we are very grateful that the grand ceremony of Asahi Glass Foundations can be organized with the physical participations. Our researchers have waited for this event for quite a long time. Due to pandemic situation in the past 2 years, we are not able to organize in a normal conference. Or they say a real conference. So now this is a real conference. So the Asahi Glass Foundations and ITB has been working together since 1988, if I'm not mistaken. So it's been a long cooperation. So we are very grateful for your long-standing support. And this overseas research grant has been giving us high impact to improve our excellent research culture at ITB. So very important programs. So we are proud with these collaborations. So these collaborations will advance the science, technology, arts, and social humanities as well. So, and the collaboration will last until 2024, and we hope that we can extend the collaboration. And hope that Asahi Glass Foundation active role, will give us a great future to still invent the science and technology. We hope that today's seminar can also broaden our knowledge of science network. So I would like to wish have a nice and fruitful seminar today for our ITB fellows, lecturers, professors, and students. So this is a pre-opening address. So there will be a real opening in the noon session with the chairman of Asahi Glass and the ITB leaders. And thank you for Mr. Watanabe and Mr. Tsumatsu for visiting us to Indonesia. So thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Ladies and gentlemen, we would like to invite Mr. Shin Tatematsu, the director of Asahi Glass Foundation, to give the pre-opening address.
So I was asked 10 minutes before to have a speech. So today we cordially thanks all of you for holding this very nice ceremony and seminar, including 14 presentations. So, as Rina-san explained, Asahi Glass started its business since 1972, and Asahi Glass Foundation started the ITB's research grant in 1988. So it took 34 years. We have been granted the research funds to your university. So the collaboration will contribute to Japan and Indonesia relationship stronger, I think. So, and the science and technology will be for stronger, strong future for our mutual prosperity. So today we will enjoy the seminar and fruitful discussions. So thank you again for joining us today.
Arigatou gozaimashita. Distinguished guests, ladies and gentlemen, now we have come to the seminar's first session on energy, disaster mitigation, and material science that will be delivered by the following research grantees. Nur Rahman Wijaya, STMSC, from the School of Architecture, Planning and Policy Development. Dr. Tek Dudi Darmawan Wijaya, STMSC, from the Faculty of Earth Sciences and Technology. Dr. Kendra Gunawan, STMSC, from the Faculty of Mining and Petroleum Engineering. Dr. Megawati Zunita, SSEMSE, from the Faculty of Industrial Technology. Dr. Eng Yosi Agustina Hidayat, STMT, from the Faculty of Industrial Technology. And Azania Fibriani, SSEMSE, PhD, from the School of Life Sciences and Technology. This session will be moderated by Kiki Adi Kurnia, PhD from the Faculty of Industrial Technology. Dr. Kurnia, time is yours.
Guests, honorable guests, ladies and gentlemen, good morning. Thank you for coming to the grand ceremony and seminar of research finding assisted by the Asahi Glass Foundation. My name is Kiki Adi Kurnia, PhD. I will be the moderator for this morning session. For each speaker, we will give around 15 minutes that consists of 10-minute presentation followed by 5 minutes of question and answer. So without waiting any longer, please welcome Nur Rahman Wijaya. Yes.
Thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Please introduce myself. My name is Nur Rahman Wijaya. I'm from Department of Urban and Regional Planning, School of Architecture, Planning and Policy Development at IBB. First of all, I would like to thank from the Asahi Glass Foundation for the research support funds for this research, which is the title Assessing the Renewable Energy Source Potential Using GIS AHP based on the model in West Java Province of Indonesia. And I'd like to introduce my teams. Myself, Roman, and also there's Al-Hilal Football, and also the student assistant, Haipan Muhammad and Dan Ustad. Okay, for the introduction, as we know that the climate change is one of the global environmental issues in the worldwide, also in Indonesia. We have this challenge, and this also as proposed in the Paris Agreement and become the international challenge. And one of the concerns, how to reduce the global emission and how to mitigate and how to adopt the energy models to minimize the climate change impact, particularly how, by using the renewable energy source. And the aims of this study is to analyze the renewable energy source potential distribution in West Java Province and identify the area with the most suitable to develop the renewable energy infrastructure. West Java Province is selected as the case because we know that the province is the most populous area on Java Island, and also is the highest of the density in Indonesia. It includes 9 cities and 18 regency, as you can see here. And yeah, the method or the analysis method framework start from we collect the data. Especially, there are 3 renewable energy source that we analyze, like wind power and solar power, and also the biomass energy. So from the analysis, we use a allocation model designed by combining a GIS, Geographical Information System. So for the decision-making method, we use a HB analytical calculation process by using some criteria. And then we can get the weighted score, and also we have the result in the end. Here we see that there are some constraints that we have to consider, like they are already have a built-up area and also some location that already have infrastructure that already built in Java province. And then the result from the potential solar energy, usually in kilowatt per hour. You can see here that the most suitable area is in the north area, and there's some area that less suitable for the solar energy. Okay, and for biomass potential, we use from the satellite image with the NDVI, mostly in the Java province is suitable. Like we can see from the green, the light and the light blue is the less suitable. And for wind power density potential, this is the area that has less suitable, because maybe not much we know that the typography and geographical of the physical of West Java province, that many of the hill and mountain or not much like let's see that in the east and also in the west part of the province. And we use the analyzing to overlay of all the area and weighted, and we can get the result, the energy source potential. You can see here, and then we can type by category that with red this is the less suitable and the green is the most suitable, and then so we can divide by the specific area. And the conclusion here, we can see that the suitable area for renewable energy resource development of Java can be sorted from the highest to less suitable swallow, solar, biomass, and vegetable wind energy. And however, the renewable energy source potential development depends on the other factors that we can include in this study, such as the proposed technology to convert the renewable energy source to electricity. And of course, there are also political and socio-economic that we have to consider. This study can contribute to renewable energy source policy planning and management. As we know that the Ministry of Energy and Resource derive to all the province government to make a local energy planning. So in Province Java, there is a planning of local energy planning for 2018. So it will be beneficial and can be input for the device for the and of course, analyzing the location for renewable energy potential for single or combined wind, solar, and biomass energy are essential for efficiency consideration for energy security and global emission reduction. The combination of GIS and HP can enlist the current method for assessing renewable energy source potential. However, it can be improved through further study regarding the verification on the on-site area and availability of existing energy source. Okay, I think that's all. Thank you for your attention.
Mr. Wijaya for my presentation. I would like to open for the Q&A session. Maybe we start from our Japanese partners to start with.
I'd like to ask one question. Probably installation cost of the solar, wind, and the biomass might be different. Efficiency point of view, you have analyzed the very suitable figures. Are you planning to analyze, including the economical point of view, which is the most efficient but less cost? Something like that.
Thank you for the question. I would like to respond the question. Yes, cost also the financial is one of the factor that very important to operate the renewable energy source development. However, in this study, I didn't include much to analyze further about that. But here, one of the factor I input this in the decision-making analysis in AHP. I put as one of the criteria financial or cost to build the biomass or solar and also for the wind. And we can see that from the expert, they said yes, the operation is highest for the solar. And yeah, maybe I not include in this slide, but there is a time for this type of the solar for the renewable energy alternative. So maybe for the first study, it will be nice that we can see that I already mentioned in the last slide that we have checked what are the type of the solar technology, because as we know, there are many kinds of the technology that already work in the world, so in Indonesia. So we can use, for example, like wind power. Wind power, we can do on site the light also on shore. But here, it's nice to know the distribution, which are the most suitable for the three of the university. Maybe in the future study we can more elaborate for that. Thank you.
Okay, thank you very much. We open the question. Okay. Okay.
Just one question. It's a short question there. So I heard from Lino-san, the volcano is nearby the West Java. So how about the geothermal electric power station can be supplied? Okay.
Yes, good things that there are many mountain, volcanic mountains. Yeah. Here also, if we go to the north, there are Tangkuban Perahu, also active volcanic mountain. But here, I didn't put as the renewable energy source for this.
Okay, please add the constellation for the energy.
Yes. Okay, thank you. Okay.
Thank you very much. You mentioned about biomass potential area. I have a very quick clarification question. When you make a map, do you put a constraint on conservation area? Because there are a lot of conservation area in West Java, which is by regulation will not be able to be cut. The biomass will not be able to be cut as a biomass energy, and it could be quite the extent quite considerable. Thank you.
Yes. Before I make the final of the suitable map, there are some constraints that you have to consider. One of the protected area that you mentioned, the conservative area. Also the other like open area, and also the water body. So it's already in this analysis.
Okay, maybe we can open for one more question.
Thank you. My name is Faisal. I'm Roman, interesting presentation. So I have a simple question actually about the AHP method. Because AHP is somewhat subjective. So how do you handle subjectivity in your research? Thank you.
Nice question. Yes, we have to select the expert. We have some criteria, like they already know what's the meaning of the energy plan, and also they know about the renewable energy source and everything. So they also have some criteria that we have to consider before we go to give the questionnaire for the AHP. So it's to reduce the bias from the results of AHP.
Okay, due to the time constraint, thank you very much for the question and answer. Please give applause for Mr. Jay. Call for the next presenter, Dr. Teh Yudi Darmawan Wijaya. Please go.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. My name is Dudi Wijaya, and I'm from Geodesy Research Division. We were working with some PhD students and also with the postdoctoral researcher to accomplish all these work which we have done during the last years. And before I start my presentation, I would like to grateful thank to the Asahi Foundation and also to LPPM for financially supporting our research. Thank you very much. Let me start our presentation. I would not go into detail of our research, but we just would like to so it seems that the file that I sent to LPPM changed it a bit. So it should have been the first page in this slide, but it somehow was skipped. But let me briefly mention that our research is trying to optimize our satellite geodesy, which is usually developed for positioning, surveying, and mapping. But in this case, we are gonna try our space geodetic techniques for capturing the atmospheric conditions. And I think we already understood that Indonesia has a lot of natural hazards. The hazards may come from earthquake and also from hydrometeorological aspect and also from anthropogenics. So in this research, we try to optimize or to apply our space-based geodetic techniques to study the hydrometeorological effect in our country's area. There is one connection between our space geodetic techniques with hydrometeorological aspect, which is the variable of water vapor. So I think we already understood that the hydrometeorological disasters such as drought, floods, typhoon, tornadoes, and heat waves, those of hazard could be driven by water vapor. And the other way around, water vapor could affect significantly our space geodetic signals. So in our purposes for geodetic positioning using space geodetic satellites like GPS, usually we try to we try to calculate the distance from the satellite to the receiver in the ground. But since when the signal is traveling from the satellite to the ground, the signal is significantly affected by the atmosphere. And in this case, our satellite is affected by water vapor. So water vapor is significant for hydrometeorological effect, and also water vapor is our enemy. So by simply developing a different algorithm, we could finally extract the atmospheric effect. So this atmospheric effect, so the atmospheric effect is noise for us. But the other way around, this could be signal from our fellows from meteorology or atmospheric physicists, so that in principle, once our signal is affected by water vapor, we could extract this information. And so I think this is the last year presentation. Not this current presentation, but I sent it my new file to Pak Adnan. So this is the last year presentation. I'm sorry. Yeah, thank you. I'm sorry. This is out of my hand. Maybe we could continue to Pak Indra, I guess. So sorry for this inconveniences. Sorry. I'm sorry.
Okay, due to some technical issue, we will continue with the third speaker for today, Dr. Kendra Gunawan.
Good morning, ladies and gentlemen. Please allow me to open my mask so that it's easier for me to speak. First of all, I would like to thank Asahi Glass Foundation for the research funding, providing funding for us to do research, and I also thank LPPM for assisting the funding through us. And my name is Kendra Gunawan. I'm a researcher in Global Geophysics Research Group, Faculty of Mining and Petroleum Engineering. In this occasion, I will present our research titled Hunt for Fault Sources Responsible for Damaging Jakarta Metropolitan Area Environmentally. And thanks. Okay, basically, Japan and Indonesia, we have similar tectonic condition. And if you look at this figure here, we have earthquake, the circle, a gray circle, showing the earthquake happened along the plate boundary. And this is Indonesia, this is Japan. And if we remember in 2004, in Indonesia, in north of Sumatra, northern part of Sumatra here, we have 2004 Sumatra Andaman earthquake. Why it's called Sumatra Andaman? Because the rupture extends northward toward Andaman, in Myanmar in here. The magnitude itself was 9.2. And in Japan, for example, if we recall again, in 2011, we have the Tohoku Oki earthquake with magnitude 9.0 happened here. So we have similarity in Japan and Indonesia. And next one. And if we look at our island right now in Java here, the southern part of Java, we have megathrust called Java Trends here. And right now, we don't have a big earthquake yet along this megathrust. And what is this figure show, the red color, basically the earthquake potential that may happen in the future. It may happen in our time, it may happen in our next generation, but the earthquake potential showing by this red color is about 8.9. So 8.9 in the western part and 8.9 in the eastern part of Java. And what the blue color showing here is the deformation after the 2004 Pangandaran earthquake. If you recall again, in 2006 Pangandaran earthquake, we have one village just completely destroyed by tsunami, and in the southern coast of Java here. So what this blue color here suggests that the deformation is continuously happened at least until 2010. And if you look at the inland part, we have the solid blue line suggesting the active fault in inland of Java. And we are right now in Bandung, and slightly 20 kilometers northward, we have active fault here called Lembaga fault. So the slip rate itself is not big, it's just about 3 to 6 millimeter. But if you accumulate those millimeter level into 200 or 500 years, then it may rupture, it may happen sudden movement called earthquake, and then it may happen with the magnitude 6 or 7. So this earthquake potential in Lembang, basically there are a lot of investigation on it. Next one. And what I'm going to share to you right now is 2019 earthquake Banten. It happened in here. It's not inland, it's offshore. It's not far from the coast of western part of Java. But what it did is that the shaking itself was felt up to northern Sumatra and also western part of Java and also Jakarta. So the earthquake is not inland, but the shaking happened all around this region here. And 4 people died because of this earthquake. And about 200 houses next door was destroyed. And we don't know the fault source of this. So if we look at this called pitch ball or focal mechanism, there are 2 possible ways. The first fault is either it's dipping to the northwest. The second fault is either dipping to the southeast. Which is the geometry, we don't know. That's why we're trying to understand the fault geometry of this fault to understand better the hazard in this region. Next one. This is the research question. Next. And to understand the fault geometry of this fault, of this earthquake here, we use first is GPS data. And then the second tools we use is tide gauge, as shown by the yellow square here, to model between the tsunami that comes after the earthquake and the data obtained from the tide gauge. Next. So this is the first model. As I mentioned earlier, the first possible fault is dipping to the southeast. So this is the top fault. The solid black line here is the top fault. And it's dipping to the southeast. And from this first model, we create 2 possible models. The first model is that the fault itself is ruptured to the shallow part. And the second is slightly deeper. That is, the top fault here is about 25 kilometers deeper. So the first is shallow rupture fault, but the second is the deeper rupture fault. And the black factor is actually the GPS co-seismic displacement. What it tells you is that during the earthquake, the earth deformed. So that like you walk from one point to another point, then you may have a displacement. So that is what this information suggests. And using the black factor, we conduct inversion, showing by this red, white to red color here, and we can obtain the model. So between these 2 models, we clearly see that for the station that located in Ujung Kulon region, this part is Ujung Kulon, or this part is Ujung Kulon. Basically, this model creates better, the model explains better the data than this model. So next one. And the second model, as I mentioned earlier, is a northwest dipping fault. So this is the top fault. This is the top fault. The difference is that this model have a shallow rupture. This is shallow, very shallow, but this one is similar to the first model. That is this one 25 kilometer. And simply by looking at this displacement, especially in Jungkulon, we can see the difference that both of this model basically failed to explain the data compared to the compared to the first model here. So what our modeling suggests that probably this is the best model, which is showing that this is the fault responsible for the earthquake. Next one. Next. So using those four models, we conduct tsunami modeling, and this is the first model. And the second model, if you remember my presentation earlier, it's located deeper at 25 kilometers depth. So what happened with the deeper fault is that the tsunami didn't reach up to the surface. So like suggesting by this figure. So actually, if we have a deeper fault, then tsunami will not, or probably very small, as observed in the surface. So between the first model and the third model, this is tipping to the southeast, this is tipping to the northwest. The first model, our comparison to the tide gauge matches this model very well compared to this. And next one. And the next step we did is to analyze the stress transfer modeling. What is the purpose of this stress transfer is basically if we have a fault rupture, and then the stress will transfer to the surrounding region. And the aftershock or earthquake happen after the main shock should occur in the what is red color here, suggesting that the positive column stress change. So if we look at this four model, we clearly see that the first model, the one our preference before, is supporting the idea of that the main shock transfer the stress and where the aftershock occurred, as shown by the red color here. But in the second model, all of the aftershock occurred in the blue region or in the transition between the blue and the red color. And next one. So,
sorry to interrupt, you have 1 minute.
Okay, thank you, moderator. This is my last slide. So I'm really reminded by the moderator. And to conclude that we have done investigation of the fault source, which, as I mentioned earlier, the impact of the fault is creating a shaking up to Jakarta, although the fault itself is located offshore. And we conduct for modeling to understand the fault source of the earthquake, and we conduct tsunami modeling from the GPS inversion, and we conduct the stress transfer, and we found that the fault source is east, northeast, and west southwest direction with the tipping to the south. And this research has been published a few weeks ago in this journal. I am myself as the first author, and along with me is my colleagues also from the National Research and Innovation Agency of Indonesia, and also my colleagues in ITB. So finally, last but not least, I would like to thank again Asahi Glass for providing the research grant to make this research happen. Thank you.
Okay, thank you very much for very insightful talk. Maybe Mr. Watanabe, do you have any questions?
Thank you very much. At first, you mentioned that the situation in Japan, but your analysis is based on the situation of Indonesia. By utilizing your established modeling and measuring method, do you have any plan to apply to Japan?
It's an interesting question. So what happened in Japan is more advanced than Indonesia. So if there is, for example, the 2011 earthquake itself. If I'm to search the published paper of the 2011, it's double, if not triple, than the earthquake investigated in Indonesia. So because a lot of scientists, even myself, study in Japan, and for us, Japan is one of the benchmark for understanding, for learning how is the tectonic process, how to understand. So it's an interesting question, but I think Japan is much more advanced than in us. So probably in Indonesia, we don't have many scientists working in earthquake, and I hope that this presentation also can attract students who could study earthquake, because in Indonesia, especially because, like I mentioned, Indonesia, we really don't have earthquake scientists as much as Japan. Thank you very much.
Thank you. For Mr. Tatamasu, do you have any question for Dr. Gunawan? Okay, we are going to open the question to the audience. Yes, Mr. Dr. Faisal.
Yeah, thanks for the opportunity for asking again. So a very interesting presentation, Dr. Gunawan, and also congratulations for the publication. So my question is, as you mentioned that Indonesia monitoring on earthquake is maybe not optimal. We need more monitoring. Is that what you said earlier?
That's one possibility.
One possibility. So my question is, for the case of Lembang fault, how can we increase monitoring in Lembang fault, because it's the risk is there, but as you said, it's under monitored. And do you have any idea how to increase monitoring in maybe cost efficient way? Thank you.
Thank you for the nice question. So probably the question is about Lembang fault, which is 20 kilometers northward from our position right now. And in Lembang fault, we have our group actually have GPS monitoring in there. We have 6 GPS station, continuous GPS station to monitor the movement or deformation related to the Lembang fault. And in addition to that, earlier this year, the National Research and Innovation Agency, or Indonesia we call it BRIN, they also add another GPS station and seismic monitoring. And that is not include the seismic monitoring as observed by a group in ITB also, and also, for example, PMKG also, they have monitoring, earthquake monitoring, seismic monitoring in Lembang. So I think there are a lot of institutions in Bandung, especially, and in national agency also, to monitor the Lembang fault. But there is the part of science. What is needed is not just the part of science, but bring the science back to the community. So sometimes in community itself, they don't need the information of deformation monitoring in millimeter level. It's the information for scientists to understand more about the tectonics, but for community itself, how they prepare when the earthquake happens, how to behave and how to make a proper building, for example. Because what we notice in Palu, for example, they just make the building simply just it's not proper. So then when the earthquake happened and it's destroyed, and again something collapse, damaged building collapse. So what I'm trying to say here is that to reduce the risk or to perform hazard risk associated to Lembang fault, we need all the science, or we need all the knowledge we have, especially in ITB, not just science, hard science, but also social science or communication science, to bring all those knowledge to the community, to the people. So Thank you. That is my answer.
Okay, thank you very much. Maybe the discussion can be continued during lunch break. Okay, applause for Dr. Gunawan. Before we continue with the next speaker, I would like to recall again Dr. Teh Dudi Darmawan Wijaya to resume the presentation. Maybe you can use the provided podium. If you want, you can use the provided podium to give the talk there. Okay.
Okay, thank you very much for the second opportunity. I'm really sorry for these inconveniences. So let me repeat again that our research is trying to optimize our genetic space techniques for hydrometeorological disasters in Indonesia. So the hydrometeorological disasters is not the most dominant one. The most dominant one is earthquake, like Pak Enrahesh nicely shown to all of us. But hydrometeorological hazard is a frequent hazard that make our monetary budget somehow collapse some years ago. So that we are trying to give something to this problem according to our techniques. So originally our technique is for surveying and mapping, but we try to optimize our approach, our specific techniques for mitigating the hydrometeorological disasters. So as I said earlier, that our connection is on the water vapor. Water vapor is a driving factor for hydrometeorological disasters like drought, floods, tornadoes, heat waves, and so on and so on. And in the other way around, water vapor is also our enemy because the water vapor can affect the accuracy of satellite positionings, including GPS, the one that you are using with Gojek and so on. And next one. Yeah, so principally, for genetic positioning, if we use GPS, we need the straight line distance between satellite receivers. But since we have atmosphere and we have troposphere, and then our signals would next, what is okay? Yeah, so that our signals will be affected by this atmospheric effect. And the most important thing is the water vapor, so that our observed distance would not be straight line anymore, but somehow curved line. This curved distance is due to the atmospheric effect. And by applying some algorithm, we could finally extract these atmospheric effects. And this atmospheric effect will be eliminated for genetic positioning. But the other way around, this atmospheric effect is important information for our colleagues from meteorology or atmospheric physicists. And this is just one example of how we get this water vapor precipitation from GPS satellites. And this is the time series of water vapor in Bako site, which is located in Cibinong, Bogor. And we could see that starting from 2002, it seemed that the water vapor increased. So it could be the humidity around Cibinong, Bogor much higher than previously. And also, if we could see the pattern of the time series, we could obviously see the periodic pattern, annually, semi-annual, or even monthly. So this is really important information that we could derive from GPS, one of the satellite jersey. Then when we analyze all the GPS stations in Indonesia, we have already almost 300 GPS stations in Indonesia, which are maintained by Indonesian Geospatial Agency, or BIG. And according to this basic time series, basic data, we have done several researches, which are accomplished by some of my students and my colleagues, postdoctoral students. And here I just would like to briefly show the result of one of all of the research that we have conducted based on this time series of water vapor. So this is the first topics that we try to study the rainfall using GPS satellites in the Sumatra Highlands. We have 75 stations here in Sumatra Highlands. The idea is to investigate this. Our data is we want to know the effect of the migration of the monsoon migration, Asian and Australian monsoon migration, which go back and forward along this direction of Sumatra. So this will be a good case for Sumatra to see the direction of movement, the Asian and Australian monsoon. So here we just analyze the annual and semi-annual. We could see that this yellow color shows that in this area, rainfall occurs once in a year. But in another area, and this is just the boundary, in the northern part area, the rainfall occurs twice a year. So from this result, we could see that Sumatra is divided by two climatic zones, which occur twice a year and once a year. And we could see also from this time series, this is just a few stations that we estimate. But the bottom line of this research is from our time series, from space-dating techniques, we could provide the rainfall characteristic, at least annual and semi-annual patterns. And of course, if we analyze into a little bit shorter frequency, we could see the daily or perhaps monthly. And this will be put for another research. And for the next research this is done by my postdoctoral colleague, Dr. Nabila, who is also here. She's trying to analyze the tropical cyclones which occurred in Nusa Tenggara Timur. And we use some GPS station in Nusa Tenggara Timur. We just show two of the stations, which is clearly capture the cyclones occurrences. So this the gray dashed vertical line is the time where the cyclones passing over this station in Nusa Tenggara Timur. So we could see the dramatic changes of this water vapor. So this is also one of our findings that the space-based geodetic techniques can obviously observe the phenomena of tropical cyclones. And also we use another satellites, because satellite geodesy has many types, GPS, altimetry, and so on. But all of these satellites were originally developed for positioning purposes, but we're trying to little bit change the algorithm so that we can also observe the atmosphere. So this is still under our investigation, but at least from this preliminary result, we could finally obviously see that the cyclone can be detected by our GPS data, of course, with some tremendous effort to get these figures. And if we compare with the surface pressures, and also has a nice correlation in a negative way. So I think this information could be also important for our colleagues from the Department of Meteorology. And currently we are cooperating with Badan Informasi Geospasial. We are trying to set up the automatic water vapor processing, and this system is regularly estimate every hour all the water vapor data from all the GPS stations in Indonesia, which are maintained by PIG. So this is still our investigation, and perhaps we could also report this research in the next Asahi seminar. And we also try to use another satellite, which is altimetry. Altimetry is dominant over the ocean. The GPS dominant in land. So this is again related to oceanic tropical cyclones, and this research was accomplished by my undergraduate students under my supervision. So this is just the anomaly of the sea surface height, water vapor map over the ocean, which are derived from satellite altimetry. So if we see the red color, so it could obviously see that our satellite altimetry could track the passing of the cyclone. So of course, this needs to be further investigated, and we are still working on it. And this is the last of my presentation, I think. So one of our researchers has been published in the Journal of Atmospheric Research, which is Q1 level. And more papers are in writing. So thank you very much.
Dr. Wijaya, for a very nice talk. Maybe we can start with Mr. Tate Matthew, if you have any question, or Mr. Watanabe.
My background is organic chemistry. Very far from this presentation. But I'd like to make sure that in the case of the water vapor is more than before, the reduction of the signal from the satellite might be decreased more. Can you take into account that the signal reduction?
Okay, let me first again, let me show again this. This is an overview of. So this is, so we quantify the reduction due to the water vapor is by calculating the bending of the signal, Sensei. So the more bend the signal, the more water vapor is there. So for us, this is a very, very bad condition. If the signal is too much bending, this is horrible for us. But this fact really important for our colleagues from meteorology. The more bend, the more water vapor, then the more information is there. So this is what that is. Thank you.
Okay, maybe from the audience, we will open only one question. Any question from the audience? Or maybe Dr. Faisal want to ask again? No more question for Dr. Faisal. Okay, thank you very much.
Thank you.
Wijaya.
Thank you.
For the next presenter, I would like to call Dr. Megawati Zunita. This one related to organic chemistry.
Good morning, everyone. Okay, I will introduce myself first. My name is Mega. You can call Mega. I'm from Chemical Engineering Department. Here, I want to represent our teams to share about our result about formic acid production. I'm sorry. How to use it? Back here, okay. And then for pointer.
Maybe if you have to move the slide from the operator, you just need to use the pointer.
Okay. So how to use it? For point. Sorry. It's okay. A related background, you are from organic chemistry, so we can discuss further. I will present here, not there, to make sure all of our presentation can deliver very well. Okay. Okay. Perfect. Okay. I want to introduce first again. Yeah, my name is Mega. You can call me as Mega. I want to present our teams. This is my master students from chemistry department. Yeah, and then this is my college, Budiana and Pak Wenton. Yeah, and then for our research about formic acid production from cellulose. Yeah, we use ionic liquid based process. Yeah. Okay, this is the background. As we know, we have non-renewable energy, yeah, like fossil, and then coal, nuclear, and natural gas. But we should shift it. Yeah, we should shift into the renewable energy, like a biomass, hydropower, geothermal, wind, sun. Yeah. As we know, the lignocellulosic biomass is abundant in our country. Yeah. We have so much waste from the natural resources, so we can use and we can process to be valuable chemical products like 5-hydroxy methylfurfural, oxalic acid, levulinic acid, and the last is formic acid as the hydrogen agent, like that. Yeah. So we can use this, use it as a fuel, biofuel. Yeah, biofuel, like that. Okay, yeah, we can see here the renewable energy potential in Indonesia. One of the resource we can use, yeah, this is the biomass. Yeah, unused potential is 99, so we can use optimizing of the utilizing of the biomass to get the valuable chemicals and bioenergy, especially for this research. Okay, yeah, this is some study of the art of our research. We can see here the conventional method for biomass conversion. We still use transition metal catalyst. Yeah, and then what's the result? The result for the formic acid field still low. Yeah, 37 until 64.7%. Yeah, and then some disadvantage should be avoid, like the toxic properties of vanadium. Yeah, high cost and difficult to recycle. So we should shifting to green chemistry principle. We use ionic liquid. What is the ionic liquid? Yeah, the ionic liquid is something unique compounds. Yeah, we can use as the media or solvent to biomass conversion. Yeah, and then this is the last reference. This is my research. Okay, so for the this research, which funded by the Asahi, we use 1 decil 3-methyl imidazoline bromide as the solvent and mediator reaction in conversion of cellulose. Okay, this is the synthesis method. Yeah, we can see here. It's so simple. It's so simple. Just we can mix of the methylimidazole and the bromodecan, yeah, and then we can get the pure product of the DMBR. Yeah, why we choose the DMBR? Because it has hydrophobic properties. Yeah, we know the biomass products. The properties is hydrophilic, so we can directly separation between the product and ionic liquid, so we can easily do regeneration of the ionic liquid, and we can use the ionic liquid to the next biomass conversion, like that. Okay, this is the conversion process of the cellulose. We can see here, we put all of the biomass in, I think this is like ampoule, yeah, like ampoule, we close all of the things, yeah, and then we react it in the oven, yeah, for 2 hours, and then after 2 hours, we extend it with the inhibitor, and then we get 2 pastes. For the first paste, we characterize with the DCMS, that's chromatography mass spectrometry, and then the next phase, we recycle the ionic liquid with the solvent dichloromethane. So we can get back the ionic liquid, and we can use again as solvent and media for cellulose conversion, like that. Okay, this is the result. I think, Professor, you know to read the spectrum. We can see here the DMBR FTIR from the precursor to be, I'm sorry, this is still in Bahasa, to be the DMBR, like that. Okay, this is the NMR spectrum. Yeah, to make sure and to elucidate the the product of the ionic liquid, so we can ensure the ionic liquid has been synthesized. Okay. Okay, this is the last one. Yeah, the last one of my presentation. This is the result of our products. Yeah, from the cellulose conversion. We can see here we did some various of the condition. Yeah, from temperature here, and then we use acid catalyzed as the Lewis acid. Yeah, Lewis acid to improve the performance of the ion liquid to cellulose conversion. Yes, we can see here the product like HMF, hydroxymethyl furfural, with the yield of the 60.28. This is for the temperature is 130. Yeah, but we can conclude for the for this condition. Yeah, for this condition without the addition of the sulfuric acid, the best condition to get formic acid or to produce formic acid is at 150 degrees Celsius. Okay, and then this is for the next. We use sulfuric acid. Yeah, 0.2 polar. Yeah. And we get the formic acid higher than without use sulfuric acid. We can see here at the 150, we can get formic acid until 73.24% like that. And then we optimize it again, yeah, to make sure what's the optimal condition to get the formic acid. Yeah, this is our aim. Yeah, our objection of this research. So we add the sulfuric acid at 1 polar, and then we decrease the temperature at 114, and we can get formic acid until 89.32%. Okay, this is the conclusion. So the best condition to formic acid production is at 140 degrees Celsius. Yeah, with the yield of the formic acid of 89.32%. Yeah, and then if we will to produce HMF, this is very valuable compounds for our future. Yeah, we can get at the condition of the 140 degrees Celsius, which has reached the yield of the HMF 91.58%. Okay, and then we regeneration of the ionic liquid like before, like previously I explained. Yeah, we can get the recovery of the demi-BR until 53%. Okay, this is our reference as our publication. Thank you.
Thank you very much. Okay, I'd like to ask Mr. Watanabe. I'm sure you have a lot of questions.
Yeah, please.
Thank you very much.
Yeah.
First of all, I'd like to mention you use the cellulose as a raw material. Is it pure cellulose without lignin?
Pure cellulose.
Yes, but in the case of the biomass, it contains a lot of lignin.
Yeah.
It is very troublesome, I think.
Yeah.
Please consider how to
to make sure all the lignin to be separate in the first step.
Yes.
Yeah.
And the second question is isolation of the product from the ionic liquid might be I think it's easy just to evaporation.
Yeah.
I only click have a very high boiling point, therefore it's very
Yeah.
easy to isolate. Am I correct?
Yeah. You are correct. They're so unique. So I choose this material. Yeah. You're welcome. So maybe we can collaborate.
Okay, Mr. Tachimatsu.
So you mentioned in the so as for the 150 degrees C, the main product is formic acid, right? And 70 degrees C, and then hydrosulfuric acid 0.2 molar, acetic acid and tetrahydrofuran is main products, not formic acid. So I was wondering, maybe the formic acid there's no carbon-carbon bond, and acetic acid and tetrahydrofuran is a carbon-carbon bondage.
Yeah.
I think it's very strong.
Yeah.
So why formic acid converted to acetic acid, or I'm not sure that maybe could you consider the reaction path of the decomposition of cellulose?
Yeah. Yeah. Okay. Very good question. Yeah. The composition is the important thing for the biomass conversion from cellulose. Okay. So why the ratio of the ionic liquid and the biomass should be 1 and 5, like that. And then we should make it through the temperature to make the formic acid for the less of the compounds from the biomass conversion. Yeah, we should increasing temperature like that.
So
yes.
Maybe you mentioned that if you put the formic acid to as a raw materials, maybe it's convert to rubric acid or acetic acid.
Yeah.
You make sure.
Yes.
Okay. Thank you very much.
Okay, thank you for the question. Open to the audience if there is any question.
Please, maybe from chemistry department or chemical engineering.
If there is no question, since my research also include the question.
It's my partner in laboratory.
Okay, so you mentioned that you use the DMIM due to the hydrophobic nature of this ionic liquid, right?
Yeah.
Since ionic liquid have cation, anion, chain length, why don't you use more hydrophobic anion? Let's say PF6, PF4.
Yeah,
something like that.
Yeah, very good questions. Yeah, because in our lab just have for anion from bromide.
Okay.
Yeah.
So,
but for the next research, I think we can change to make some. Yeah.
Or maybe in other words, you need more grant.
Yeah.
You can request to the Asahi. Okay. If there is no more question, thank you, Dr. Mega. Please give applause to Dr. Mega. I would like to call for the next presenter, Dr. N. Yosi Agustina Hidayat.
Okay, very good morning, ladies and gentlemen, and also professors and colleagues, students. Today, I would like to present our research entitled Reverse Supply Chain Conceptual Model to Reduce Plastic Packaging Waste as Results of Increasing E-commerce Sales During COVID-19 Pandemic. So, is Yosi Agustina Hidayat, and I'm from of Industrial Technology, Bandung Institute of Technology. Next, please. Okay, coming into the introductions that Ministry of Environment and Forestry stated that Indonesia is the second largest plastic polluter in the world during the year of 2020. And this statement from the Ministry of Forestry is supported by the data that shows that 3.2 million tons of plastic waste, which is 10% of total waste, are dumped into the world's ocean annually, and it also affects the Indonesian river. And this number is predicted to be twice until 4 times larger within these 15 years. And the majority of municipal waste are generated from the household. This is certainly correlated with the origin of household waste, which is general in plastic packaging waste form. The data shows that the largest plastic manufacturing industry come from the 36% of the plastic packaging industry. And one of the products that are closely related to the plastic packaging are the household of personal care and home healthcare products. And we can see that more ironic that only 10% of total plastic waste are being recycled. So the recycle strategy should be supported by another reverse logistics strategy, which is reuse and refill strategy. Therefore, Indonesia has faced with a challenging problem in waste management, and recycling is not enough to solve all the plastics problem. And the alternatives that are proposed in this research in order to create sustainable packaging is reuse packaging and refill product concept. Actually, in Indonesia, there are few business that engage in refill and use service provider packaging. 3 of the company is Kiosk, Coinpack, and Cellulose, we call it, that utilize reuse packaging and refill product concept as their core business process. But unfortunately, these 3 companies is very young, relatively young established company on start their business from 2020. Therefore, the objective of this study, you can see in the bottom right square, that to understand the customer preference about the reuse and refill service, in particular in the personal care and home healthcare products. Next, please. So we are coming into the methodology. To achieve the objective of the research, as mentioned before, the research starts with the defining the problems of the increasing number of plastic waste from personal and home healthcare products. Then it continued with designing the research by developing questionnaires, consists of 60 questions, and constructing data collection strategy. During the data collections, we are distributing some questionnaires to the users who are over 16 years old of age and has the purchase experience of the personal care and home healthcare products by themselves. Then we make some data pre-processing analysis
by first visualizing and interpreting data. After that, a report is constructed in this research to deliver the insight gathered during the study. So according to the data collections, we can gain some demographic information that we were successfully collected 795 respondents. The 94% are female of these respondents, and the rest of 6% are male. And related to the age group, most of the respondents are in between 26 until 35 years old of age. By the spending of $80 until $250 of expense for the customer goods product monthly. And related to the family status, most of our respondents live with the family with average of 4 family members. Next, please. According to our result, for the customer preference related to the service preference, customer prefer to use their own bottle compared to the refill process with special bottle or borrow refill bottle from service provider. So this is the results, but actually they have indifferent options or preference about the refill process option, whether the refill process options are exchange empty refill bottles to the refilled one. Either the refill process is related to the refillable bottles using a special automatic machine, or give bottles to the operator to be filled by the operator. There are no indifference of preference of the customer. And what the interesting thing is that a customer prefer to make payments in cash rather than non-cash payments, but they prefer to do the online order to get the product refill service. And related to the refill product size, of course, they want to be the size that they want to be. Sorry. Next, please. And when we go into detail about the 2 products, the first one is personal care product and the second one is a home care product. Related to the personal care product preference, customer prefer to have body wash and shampoo products in the form of refill products with the size of 250 milliliters and 500 milliliters from well-known brand. For example, for the body wash, they prefer to do the refill and reuse product from Lifebuoy and Lux. While from the shampoo, they prefer to make the refill and reuse procedure from Pantene, Dove, and Lifebuoy products. And the frequency of refill and reuse is in average is 1 until 2 times per month. And for the very first time, they want to buy the bottle packaging, but the next refill process, they tend to buy the refill pouch packaging for the second time, and so on. The similar results is that for the home healthcare product preference, the respondents prefer to have liquid detergent and dishwasher soap in the form of refill product with the size of 500 milliliters and 1,000 milliliters from well-known product brands such as Soclean, Rainfall, Sunlight, Mama Lemon, and Whipple. And the purchase frequencies is 2 times per month. And same as the personal care products, consumer tends to buy home healthcare product in the bottle packaging at the first time, and to buy in refill pouch packaging for the second time, and so on. But unfortunately, there are still a few number of respondents, as 31%, who admit that they have used the refill service, although 71% respondents actually already known about this business related to the refill and reuse service concept, but they don't know how to achieve this or to reach this business. Hopefully, with this research, more people can take advantage to refill service, especially for personal care and home health care products. And coming into the conclusion, next please. Yeah, there are some insight, recommendation, and the future research we would like to highlight in this Asahi grant research output. So based on this research, there are several recommendations worth to be considered. The first one that since the customer buy product in bottle packaging for the first time and then switch to the refill pouch packaging after that, moreover that 99% respondents actually have the willingness to use the refill and service and reuse concept either without any discount or any subsidy. This is a very good news because they are voluntary want to participate in the green environment participations actions. And the reuse and refill process is very good to replace the purchase behavior, but without any involvement of plastics packaging. Another important thing is it is needed to develop more service in order to reach wider targeted market. And in terms of marketing and pricing, this is related to the company perspective or the preferred brands of the customer. It is recommended to construct strategic partnership, environmentally friendly sales channel between the manufacturing company of the preferred brand with the reuse and refill service provider businesses. And for the research, we also asked the customer what is their concern related to the refill and reuse product. They are very concerned with the hygiene and authenticity of the products. So in the future research, we would like to consider this factor in order to develop the reuse and refill process. Also, we would like to extend this research by calculating the potential of plastic waste reduction by using the concept, by using dynamic system, but unfortunately, the data is not enough because the business is starting from 2020. And moreover, we would like to generating more specific business or plastic waste reduction strategy by using the multivariate analysis, in particular using the cluster and factor analysis. Next, please. I think that's all for today's presentation. Thank you very much. I would like to thank to Asahi Grant Foundation to support this research and make this research happen. Thank you.
As per usual, we would like to ask Mr. Watanabe or Mr. Tatamatsu if you have any question. It's not organic chemistry.
Thank you very much. And in the case of refill, why do you stick on the plastic bottle? You can change to the glass bottle or something like that.
Okay, thank you very much for your questions. We concern about the plastic packaging since the type of packaging is the most affordable one to our society, and it has a dominant preference. But in the other hand, related to the bargaining power of the customers, it is also give some contribution to the waste. And as we know that the refill plastic packaging for the soap, shampoo, etc. is consists of some material of polypropylene, etc. While the plastic packaging for the water such as aqua from Danone, they have already has the established system for recycle. But unfortunately for the customer goods, either outside the mineral water, they still have no system of good system of recycle. So we have to think about the reuse and refill strategy in order to combine with the recycle strategy that is not enough. Still not enough to reduce the plastic packaging, and this packaging type is also according to the Rakuten in 2019, 2020, this is the most tremendous e-commerce sales increase for the customer goods in Indonesia. That's all. Thank you.
Thank you.
Thank you. From the audience, if there is any question, yeah, we have one.
Okay, good morning. My name is Nabila. I would like to ask a question about the demography that you mentioned earlier. So I saw that 94% of the respondents are women, but only 6% are men. So my question is, why is that? And how did you choose the respondents for this research? Thank you.
Okay, thank you very much for the question, Nabila. So we make some purposive sampling, but we are not tend to have a target of the female or male. But the main purposive sampling of our research is related to the one who has experience in using this home care and health products. And we distribute, I think, around 1,000 questionnaires. But after the pre-processing data, we have this demographic. So the percentage of female and male are uncontrollable for our research. But later on, we are trying to make some cluster analysis or discriminant analysis or factor analysis related to the demographic results. So whether moreover, for example, the female respondents tends to make the reuse and refill for the smaller pouch of volume, and the male one is not so excited in refill and reuse strategy, and so on. But that will be on the next research. Thank you, Nabila, for your questions.
Okay, thank you. Actually, I got intrigued also with the demographic, because when I saw like 6%, does it mean the man doesn't like to buy, shower, or anything? Some product like that. Well, we don't like to take shower. Basically, we like, but I don't know, maybe we prefer to buy smaller size.
Yes.
Because it's quite troublesome for us to travel with big size of the bottle, or something like that. I mean, we are men, we like something simple.
Yeah, maybe next research we can collaborate about the preference of the men, yeah,
Okay.
relating to the strategy.
Because we are running out of time, please give applause for those of you.
Thank you very much.
I would like to call for our last presenter for this morning session, Azania Febriani, PhD.
Okay, good morning, ladies and gentlemen. So I'll be the last presenter for this morning session. I hope you still have a spirit to listen these presentations. Okay, my name is Azania Febriani. I'm from School of Life Science and Technology, ITD. And together with me is Iza Nurlaili and also Audrey Angelina Tahoudin. So I would like to talk about the biggest disaster during decades is COVID-19 pandemic, but I'm not talking about the pandemic itself. I try to tell you about the alternative solution to get out from this pandemic. Okay, my result is about the isolation and characterization. This is actually characterization of H2-like. I think the format is 2. Okay, I just read it, yeah. Isolation and characterization of H2-like enzyme from endogenous Indonesian fermented food. So before I begin the story, so I would like, I think the format is quite different. So just ignore it, yeah. I hope I can present it as obvious. Yeah. So I will remind you with the virus, the most interesting virus we are dealing with is SARS-CoV-2 that caused the COVID-19 pandemic 2 years, more than 2 years, I think. So this is the virus, the simple structure of the virus. Okay, this is a spherical like a ball. And outside this virus, there are proteins. I think most of you has the kimia dasar. So I think most of you know what is protein. So proteins in SARS-CoV-2 virus, we call spike protein or abbreviated S protein. So when the SARS-CoV-2 virus want to enter the human cells, our cells, it will use the protein in human body. Yeah, it's called angiotensin converting enzyme 2 or S2. So just imagine this is the cells of the humans, and the virus will enter through the S2. And what the virus did, you already know, it will fuse with the membrane of the cells, and it will enter the cells, and then it will replicate. And what the impact of the patients? So the impact of the patient, so actually the S2 receptor, we call it, has the another functions in health human body. What is the function of S2? So S2 actually has to degrade the angiotensin, and then it will, if there is no degradation of angiotensin or deficiency of degradation of angiotensins, and it results with the disease. For example, acute lung injury, or for example, hypertension. So what happens to the COVID-19 patients? Because the virus hijack our S2, then we have S2 deficiency. It means that we have angiotensin 2 higher in the COVID-19 patients. It means the patients can get acute lung injury. So what is the treatment? So interestingly, this S2 enzyme, there's some bacteria that can produce also the likely similar enzyme. So it's called S2-like enzyme. For example, is M32 carboxypeptidase. And very interesting, this bacteria also found in fermented food. So one of the recent study in Japan, because we have collaboration with Kyoto University, one of the recent study in Japan that show that in Japanese fermented food, there's a bacteria that produce S2-like enzyme, and this S2-like enzyme can be a potential treatment for the COVID-19, and it's already proven by in mice in animal trial. So what is the challenge? So Indonesia has a lot of fermented food. That's why in our study, we would like to search whether also in Indonesia, there are bacteria that produce X2-like enzyme. Okay, so that is our goal. So I hope you can understand from this side. So this is quite complicated, but I will try to make it simple. This is the method that we use in this result. So first, of course, because you would like to know what is the bacteria, then we have to isolate the bacteria. Okay. Then after we isolate, we will culture this bacteria in the selective media. So only media that have lactic acid activity that could live in this media. So after we get some candidates, then we test it for the enzyme activity. Name it the hydrolysis assay. Okay. So after that, we want to know, okay, what kind of bacteria that has this enzyme. So we identify this bacteria. We're using the ribosomal RNA sequencing. If you don't familiar, just ignore it for standard, we identify. And then, of course, because our goal is not only to identify, but our goal is to produce something that can be cure COVID-19. So from this bacteria, we clone the gene that can produce S2-like enzyme. And we transform it into recombinant bacteria, name it E. coli. Yeah, why? Because E. coli is easy to cultivate. E. coli is not danger to human. Okay, and we can produce in a mass scale. And then we test it again, the inhibitory assay. So this inhibitor assay, what happened in this assay is that we put protein spike from SARS-CoV-2, and also we put the human S2. And then for the third region, we put our enzyme. So if our enzyme combined with the protein for SARS-CoV-2, then there will be inhibitory assay, inhibitor effect here. Then also, yeah, because we are very interested in modeling, so we not perhaps Panda has modeling, Padude has modeling, so we also have modeling, yeah? So we have modeled this protein. What kind of model? We model the interactions between the protein and also the SARS-CoV-2 protein. So that makes our understanding better. So here's the result. We have 7 food samples, yeah? And this is tempoyak, bram, tauco, yogurt, oncom, peyem, and terasi. This is local name, so sorry. So this is from durian, yeah? This is from sugar fermentations. Tauco is from soybean fermentations, thank you. Yogurt is from milk fermentations. Oncom is also from soybean fermentations, but different bacteria. And peyem is also from cassava fermentation. So this is, terasi is mixed up with the shrimp fermentation. So we try to find the bacteria that can grow in our selective media. So from 58 bacteria, 38 bacteria can grow in our selective media. And then among these 38, 3 isolates can have the activity of the S2-like enzyme. So we identified this bacteria, and we find this Bacillus cereus, Lactobacillus delgurkeri, and Lactobacillus fermentum. And this is the proof of the analysis. So if you're not familiar, so this is the first bacteria from Lactobacillus, and this is the second bacteria from Lactobacillus, and this is the bacteria from Bacillus cereus. So it's a group with the right bacteria reference sequence. So we will, because the time is limited, so we choose only one bacteria to go further. And this is the result. So we isolate the enzyme, we isolate the gene from this bacteria, and we make a recombinant E. coli from the gene of the bacteria. And this is the SDS page called, and you can see this protein is expressed in the E. coli recombinant, and it also has the enzyme activity. However, if we compare the enzyme activity of our recombinant proteins, compare with the native protein, native means that we isolate from the Bacillus cereus, not from E. coli. So we see that the activity of the recombinant protein, it seems lower than the native protein. So we want to know what happens. So we try to model this recombinant and the native proteins, and we did superimpose. This is if you match each other. And we found that if you not see here, this is the yellow part. So the yellow part is show you the activity site. So it means that in our recombinants and native proteins, they are the site of activity of S2-like enzyme. However, there is a site for the interaction with the human S2.
Dr. Azimi, sorry to interrupt. We have 1 minute.
Okay. So this is the slide. This is very interesting. So if we did the inhibitor assay, we will see that the recombinant enzyme, both the recombinant and full-length enzyme, have the inhibition activity to inhibit the interaction between human S2 and protein SARS-CoV-2. And this is the, if you are chemist, then you can understand this. This is the interactions energy between the recombinant protein and also the RBD SARS-CoV-2. And you see, the lowest the delta gives is the most spontaneous reaction will be occur. And you see here, this very interesting that this is human S2, and these both are our isolated enzyme. And we see here, our isolated enzyme has the lower delta gives compared to human S2. It means it's promising that it can compete human S2 for binding SARS-CoV-2 virus. So I won't go to the detail, but this is for this model. You can see which amino acid residue that can bind with the protein of the virus. So this go to the conclusions. For this result, we successfully extracted S2-like enzyme from Bacillus cereus. And after the activity assay, we can see that this enzyme is not only block the virus entry, but also might lower angiotensin level 2 in COVID-19 patients. So we also want to thank to Professor Jun Ogawa and Dr. Michi Kitikawichi from Kyoto University that already support our research. And also we also want to thank to Asahi Glass Foundation that also support our research. Thank you very much.
For the last time in the morning session, I would like to ask Mr. Watanabe if you have any question.
Heavy duty. I'm sorry, it's not related. My question is not related to your research, but you make collaboration with Kyoto University. Do you face any difficulty under the pandemic situation?
Thank you for your question, Mr. Watanabe. Actually, one of our member teams is a master student and also double degree student between SITH and Kyoto University. So at the first year or the second years, she worked in Kyoto University, and then she worked in our faculty. So Ogawa Sensei and also Takauchi Sensei is very helpful. So during the pandemic, of course, they cannot come to Indonesia, but we correspond through Zoom, online, I mean. And for example, the subtrans and also the control for our research, they send us. So it's very helpful. So during the pandemic, perhaps we cannot see each other physically, but I think it's not, it's not impossible to make a collaboration.
So Professor Jun Ogawa is from Department of Agriculture. Sure.
Yes.
He is a member of Asahi Glass Foundation. You know.
And you also know that I help this grant.
Just a comment.
Okay, thank you. Maybe one question from the audience. If there is no question from the audience, let's give applause for Dr. We come to the end of the morning presentation. I would like to thank our Japanese partner, Mr. Watanabe and Mr. Tatematsu, also from the audience for the question and discussion during the morning session. And then with this, I return the floor back to our MC.
Thank you, Dr. Kurnia. All right, ladies and gentlemen, it has been a very amazing session, right? So for now, we are going to have lunch break. Unfortunately, you cannot bring food here, your lunch here. So we are going to have that in the gallery by the poster session hallway. All right. So this conference, this seminar will resume at 1:30 Jakarta Standard Time. All right. So please come back at 1:30. Have a great lunch. Thank you.
Dia sengaja belajar.
Kenapa potensial? Kenapa tadi ekonomi presentasinya saya maka di teman-teman yang potensial presenter itu ada
Siapa aja? Oh, maksudnya? Ya, maksudnya ini udah dari Kalau lah yang nggak Jumatan. Kemudian nggak. Jumatan nggak? Oh iya, nggak Jumatan dia.
LPPM aku.
Patim. Kemudian kalau sih kan bisa bahasa Jepang, Nihongo yang kelas. Josu, Nihongo Josu.
Siapa? Masih ada. Di YouTube.
Same as Gary Sensei. Also, I don't really speak Japanese, and also my Japanese is not okay. Because my friends are like university students. Maybe it's very important.
Check.
I know. So it's very, very difficult, even though I have hostel family. But I don't know, it's like love language, yeah. I don't speak Japanese, they don't speak Indonesian, they don't speak English. So if I come home, so it's just like Tadaima, itadakimasu, itadakimashita, you know, something like that. Like the very, very survival Nihongo.
Sana ada revisi
She was a specialized in Japanese education for Japanese language. So she wrote the so-called maybe very difficult case of haiku hyogen. Expressions.
So there's
somehow some other specialists.
yeah, a lot of American Jing, Indonesian Jing, it is very difficult even though I live there. This is, yeah, and my sense I speak very good English, so we spoke in English. Sometimes if my classmate, they talk to sensei, I was like, so what did you say? Oh, I said, can I come in? Oh my goodness, that long? Please have the lunch. Over there. Yeah, at the postal hallway. Okay.
Bagus. Nggak tahu ada diturunkan dikit loh. Ya. So.
They will keep this safe.
Kalian, lagi rame. Apa enggak ini makan? Habis dah.
Itu udah barusan diajak ngobrol makanya.
Ini ditutup Mbak, saya di sini. Itu kantor. Ini masyarakat kesehatan.
Makanya kan kamu di sini ya? Ya.
Cek.
Established in 1920 with the name Technische Hogeschool, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. Itebe creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. Itebe also continues to collaborate and build synergy with the government. Industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. Itebe Innovation Park in Ganesha, Itebe Innovation Park in Gadebage, and STP Vasanta Innovation Park in Bekasi. By upholding 3 pillars of education that comprise education, research, and community service, Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Teknisa Hoha School, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. Itay Innovation Park in Ganesa, Itay Innovation Park in Gede Bagay, and STP Vasanta Innovation Park in Bekasi. By upholding 3 pillars of education that comprise education, research, and community service, Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Teknisa Hogeschool, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. Industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. Ite Bay Innovation Park in Ganesha, Ite Bay Innovation Park in Gede Bagay, and STP Vasanta Innovation Park in Bekasi. By upholding 3 pillars of education that comprise education, research, and community service, Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Teknisa Hoha School, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. Industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. Ite Bay Innovation Park in Ganesha, Ite Bay Innovation Park in Gede Bagay, and STP Vasanta Innovation Park in Bekasi. By upholding 3 pillars of education that comprise education, research, and community service, Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Teknisa Hogeschool, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. Industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. ITB Innovation Park in Ganesha, ITB Innovation Park in Gede Bage, and STP Vasanta Innovation Park in Bekasi. By upholding 3 pillars of education that comprise education, research, and community service, Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Teknisa Hoha School, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. Industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. ITB Innovation Park in Ganesha, ITB Innovation Park in Gede Bage, and STP Vasanta Innovation Park in Bekasi. By upholding 3 pillars of education that comprise education, research, and community service, Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Teknisa Hoha School, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. Industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. ITB Innovation Park in Ganesha, ITB Innovation Park in Gede Bage, and STP Vasanta Innovation Park in Bekasi. By upholding 3 pillars of education that comprise education, research, and community service, Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Teknisa Hogeschool, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. Industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. ITB Innovation Park in Ganesha, ITB Innovation Park in Gede Bage, and STP Vasanta Innovation Park in Bekasi. By upholding 3 pillars of education that comprise education, research, and community service, Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Teknisa Hogeschool, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. Industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. ITB Innovation Park in Ganesha, ITB Innovation Park in Gede Bagay, and STP Vasanta Innovation Park in Bekasi. By upholding 3 pillars of education that comprise education, research, and community service, Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Teknisa Hogeschool, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. Industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. ITB Innovation Park in Ganesha, ITB Innovation Park in Gede Bagay, and STP Vasanta Innovation Park in Bekasi. By upholding 3 pillars of education that comprise education, research, and community service, Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Technische Hogeschool, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. Industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. ITB Innovation Park in Ganesha, ITB Innovation Park in Gede Bagay, and STP Vasanta Innovation Park in Bekasi. By upholding 3 pillars of education that comprise education, research, and community service, Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Teknisa Hoha School, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools, with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. Bay Innovation Park in Ganesha, Bay Innovation Park in Gede Bagay, and STP Vasanta Innovation Park in Bekasi. By upholding 3 pillars of education that comprise education, research, and community service, Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Teknisa Hoha School, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. Industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. Ite Bay Innovation Park in Ganesha, Ite Bay Innovation Park in Gede Bagay, and STP Vasanta Innovation Park in Bekasi. By upholding 3 pillars of education that comprise education, research, and community service, Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Teknisa Hoha School, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. Industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. Ite Bay Innovation Park in Ganesha, Ite Bay Innovation Park in Gede Bagay, and STP Vasanta Innovation Park in Bekasi. By upholding 3 pillars of education that comprise education, research, and community service, Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Teknisa Hogeschool, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. Industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. ITB Innovation Park in Ganesha, ITB Innovation Park in Gede Bage, and STP Vasanta Innovation Park in Bekasi. by upholding 3 pillars of education that comprise education, research, and community service. Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Technische Hogeschool, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. Industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. ITB Innovation Park in Ganesha, ITB Innovation Park in Gede Bage, and STP Vasanta Innovation Park in Bekasi. By upholding 3 pillars of education that comprise education, research, and community service, Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Teknisa Hoha School, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. Industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. ITB Innovation Park in Ganesha, ITB Innovation Park in Gede Bage, and STP Vasanta Innovation Park in Bekasi. By upholding 3 pillars of education that comprise education, research, and community service, Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Teknisa Hoha School, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. Industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. ITB Innovation Park in Ganesha, ITB Innovation Park in Gede Bage, and STP Vasanta Innovation Park in Bekasi. By upholding 3 pillars of education that comprise education, research, and community service, Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Teknisa Hogeschool, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. Industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. ITB Innovation Park in Ganesha, ITB Innovation Park in Gede Bagay, and STP Vasanta Innovation Park in Bekasi. By upholding 3 pillars of education that comprise education, research, and community service, Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Teknisa Hogeschool, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. Industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. ITB Innovation Park in Ganesha, ITB Innovation Park in Gede Bage, and STP Vasanta Innovation Park in Bekasi. By upholding 3 pillars of education that comprise education, research, and community service, Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Technische Hogeschool, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools, with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. Industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. ITB Innovation Park in Ganesha, ITB Innovation Park in Gede Bage, and STP Vasanta Innovation Park in Bekasi. By upholding 3 pillars of education that comprise education, research, and community service, Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Teknisa Hogeschool, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. Industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. ITB Innovation Park in Ganesha, ITB Innovation Park in Gede Bagay, and STP Vasanta Innovation Park in Bekasi. By upholding 3 pillars of education that comprise education, research, and community service, Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Teknisa Hoha School, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. Bay Innovation Park in Ganesha, Bay Innovation Park in Gede Bagay, and STP Vasanta Innovation Park in Bekasi. By upholding 3 pillars of education that comprise education, research, and community service, Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Teknisa Hogeschool, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. Industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. Bay Innovation Park in Ganesha, Bay Innovation Park in Gadebage, and STP Vasanta Innovation Park in Bekasi. By upholding 3 pillars of education that comprise education, research, and community service, Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Teknisa Hogeschool, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. Industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. Bay Innovation Park in Ganesha, Bay Innovation Park in Gadebage, and STP Vasanta Innovation Park in Bekasi. By upholding 3 pillars of education that comprise education, research, and community service, Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Teknisa Hoha School, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. Industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. ITB Innovation Park in Ganesha, ITB Innovation Park in Gede Bage, and STP Vasanta Innovation Park in Bekasi. by upholding 3 pillars of education that comprise education, research, and community service. Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Technische Hogeschool, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools, with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. Industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. ITB Innovation Park in Ganesha, ITB Innovation Park in Gede Bage, and STP Vasanta Innovation Park in Bekasi. By upholding 3 pillars of education that comprise education, research, and community service, Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Teknisa Hoha School, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. Industry, and other higher education institutions. This will lead to the creation of new technology. This new technology is expected to enhance the economic prosperity of Indonesia in general. One way to make this happen is through the development of science and technoparks in various locations. ITB Innovation Park in Ganesha, ITB Innovation Park in Gede Bage, and STP Vasanta Innovation Park in Bekasi. By upholding 3 pillars of education that comprise education, research, and community service, Institut Teknologi Bandung will consistently produce excellent human resources for a better Indonesia. Established in 1920 with the name Teknisa Hoha School, Institut Teknologi Bandung, or ITB for short, is the oldest technical university in Indonesia. Located in Bandung City, West Java, Indonesia, ITB now has 12 faculties or schools with 49 bachelor study programs, 52 master's programs, 27 doctor's programs, and 2 professional programs. ITB's vision is to be an outstanding, distinguished, independent, and internationally recognized university that leads changes towards welfare improvement of Indonesian nations and the world. Excellence in teaching and learning's progress is marked with an accreditation that is earned on a continuous basis. 34 study programs of ITB have received accreditation from international accreditation boards. More international accreditation boards will follow. As one of Indonesia's centers of research, ITB has produced a wide range of research from 5 centers of excellence. These research projects result in excellent innovations that are expected to compete in national and international markets, which will certainly make an impact on the economy, improving it significantly. ITB creates innovation that departs from problems in industry and communities. Research is conducted in order to deliver the best solution that will enhance production quality and resource efficiency through support of technology. ITB also continues to collaborate and build synergy with the government. Industry,
Switch.
Ladies and gentlemen, the seminar is about to begin. Mohon tidak makan di ruangan ini ya. Dan apabila minum, harap minumannya tidak tumpah. Chair of Institute of Research and Community Services, Dr. M. Yuli Indartono, Chairman of Asahi Glass Foundation, Mr. Takuya Shimamura, the General Manager of AGC, Mr. Yoshihiko Sato, LPIK officials, Joko Sarwono, PhD, and Vice of ITB Board of Reviewer, Estianti Ekawati, PhD, distinguished guests, ladies and gentlemen. Good afternoon and welcome back to this room. We are going to have the grand ceremony and seminar on research findings assisted by the Asahi Glass Foundation 2022. We will carry on with this seminar after the opening ceremony. I would like to invite the Chair of Institute for Research and Community Services ITB for the opening address and to declare the seminar open. Ladies and gentlemen, please welcome Dr. Eng Yuliandarto.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Mr. Tapia Simamura, the chairman of Asahi Glass Foundation. Mr. Hiroyuki Watanabe, senior executive director of Asahi Glass Foundation. Mr. Shin Petamatsu, Director of Asahi Glass Foundation. Dr. Joko Sarwono, Chairman of the Institute for Development of Innovation and Entrepreneurship, LPIT. Dr. Rino Rahmatamukti, Secretary of Research of Institute for Research and Community Services of ITB. Distinguished guests from Asahi Glass Corporation and Asahi Mas Chemical Indonesia. Of course, ITB fellows. I saw Professor Ferdi, Professor Freddy, Professor Sukrasno, and all colleagues from ITB. Ladies and gentlemen, good afternoon. Welcome to Panmi. This year, we are very grateful that the grand ceremony of Asahi Glass Foundation Research Grant can be organized in offline or physical participation. Our researchers have waited this event for quite a long time due to pandemic situation, global situation in the past 2 years. The Asahi Glass Foundation has been working together with IDB since 1988. This is I think, quite long collaboration, strong and long collaboration, and we hope still maintain in the future. Until now, there are 338 proposals from ITB researchers have been funded by this research grant scheme. So I think a lot of contribution from Asahi Glass Foundation for ITB. So thank you very much. The Asahi Glass Foundation, through the Overseas Research Grant, has been giving us high impact to improve our excellent research culture. I saw this morning until this afternoon that the research results of this year's recipients have been and will be presented. In this afternoon session, we will still have the presentation and discussion showcasing recent research results that shed light on important topics that has technological implication as well as advancement in science. In addition, we will celebrate the grand ceremony for the newly 14 recipients consisting of ITB prominent researchers that have been selected out of 39 proposals. We would like to inform you that the selected research proposals were evaluated by ITB Board of Reviewers. I heard that OST, representation of the Court of Review also come here. So please stand to ST, or maybe in the next room. The review using several significant criteria, including intellectual merit, broader impacts of proposed research, output target, and the principal investigator's track record. So we use quite tight criteria to select the proposals from the prominent researchers of ITB. We are always grateful to host the Asahi Glass Foundation Research Grant throughout the years. Mr. Chairman, Mr. Takuya Shimamura, we are proud that the ongoing cooperation between ITB and Asahi Glass Foundation will last until 20 and 25, and we hope we will continue the cooperation. We will extend the memorandum of understanding, I think, for these important activities between two countries. ITB shall continue to be the leader in the advancement of science, technology, arts, and social humanities. ITB will preserve its academic atmosphere that is open to new ideas and experiences. We welcome visionary and critical thought to give continuation our research activities that may give birth to potential scientists and adaptive community towards building excellent research culture. Or in bahasa Indonesia, we call it as budaya ilmiah unggul. That is our important tagline for the vice rector of the research. I would like to thank once more for the Asahi Glass Foundation active role in providing us with continuous trust and long-term support. I hope that the seminar can broaden our knowledge on science networks that are beneficial to all. Have a nice and fruitful seminar today. Thank you very much for your attention. And good afternoon. I close with Alhamdulillah. Assalamualaikum warahmatullahi wabarakatuh. Thank you. And then since the announcer asked me to officially open the session, so by saying Bismillahirrahmanirrahim, I officially open this afternoon session.
Thank you. Next, we will have a speech from Chairman of the Asahi Glass Foundation. Ladies and gentlemen, please welcome Mr. Takuya Shimamura.
Siang. Thank you very much for your kind introduction. Yang saya hormati Bapak-bapak, ibu-ibu sekalian. Selamat siang dan selamat sejahtera. Nama saya Shimamura, Chairman dari Asahi Glass Foundation dan Chairman dari Asahi Glass ADC. It is both an honor and pleasure for me to be this ceremony today. As a representative of the Asahi Glass Foundation in Japan. Firstly, I would like to express my heartfelt congratulations to all recipients of the research grant. And also, please allow me to extend my sincere gratitude to Professor Rainey Wheeler-Dixon, Director of ATB, Professor Igde Wenton, Vice Director for Research
and innovation. And also, Dr. Yuri Stiono in Daltono, chair of the Institute for Research and Community Services, our distinguished guests and members hosting today's ceremonies. Terima kasih banyak. So please allow me to say, because my private stories, I had worked in Indonesia from 2003 until 2006 as a representative of Asahi Glass Chemicals. So my family also loved Indonesia. So in fact, already more than 10 years we go back to Japan. Still my wife has Brazil Bahasa. So this time I said to her, I have a chance to visit ETB, Indonesia. She complained a lot. Why don't you take me? So I keep silent. Well, anyway, thank you very much. Secondly, let me introduce Asahi Glass Foundation briefly. It was established in 1933 to celebrate the 25th anniversary of the founding of Asahi Glass Company Limited. Asahi Glass Company Limited was renamed to AGC Inc. in 2018 during my period as the president. Now we provide three major programs, such as the research grant program, scholarship program, and commendation program, and Blue Planet Prize. In addition, we have published the annual survey on the global environment named Environment Doomsday Club in terms of the relationship between AGC Inc. and Indonesia. In 1972, AGC, then the Asahi Glass, began to produce flat glass in Ancol, Jakarta, Indonesia, and expanding its business areas to automotive glass and chemicals. Nowadays, from about accumulate investment in Indonesia up to 2.5 billion US dollars. So that's one of the biggest Japanese investors in Japan. So that means AGC has a very lovely favorite feeling, impression of Indonesia to work together with Indonesian people. Today, total annual sales revenue of group is approximately 1.1 billion US dollars in Indonesia. Now still going up. We can expect successful expansion long term. And many alumni of the ETB have joined the Asahi Glass TBK and the Asahi Chemical. In 1988, Asahi Glass Foundation initiated our grant program with ETB. So that's why this year is the 34th anniversary for both parties. For AGC Inc. and Asahi Glass Foundation have a long history with Indonesia and ATB as well. We have supported 338 grant schemes and contribute approximately 1.5 million US dollars from the beginning. I believe in these researches can contribute enough for the development and prosperity of Indonesia. We wish our support can be helpful for your researches. As one of other major activities of foundation, we provide Blue Planet Prize from 1992, which has become internationally recognized award success. The foundation has awarded the Blue Planet Prize to 2 people who have made outstanding contributions towards solving global environmental issues with a certificate of merit, commemorative trophy, and 50 million Japanese yen or 370,000 US dollars per each in prize money. From Indonesia, in the past, Dr. Erin Salim, the former Minister of Population and Environment of Indonesia, was the winner in 2006. Professor Vera Bandung Ramanasan from the United States and Professor Mohan Narasimha from Sri Lanka were winners in 2021. And the first winner in 1992, Professor Manabe, Shanto Manabe, he got the Nobel Prize in Physics last year. It's a very amazing stories. The reason why he was selected for the Nobel Prize, the reason was the same. When we selected him as a winner in 2008. So that's why this Blue Planet Prize has a lot of the big insight for the future in 2019. And this year, His Majesty Jigme Shinge Bancho, the fourth king of Bhutan, and Professor Stephen Carpenter from the United States are winners. If you are interested, please visit our website, which explains the winners' achievement in detail. And you can also reach the name and the research themes of this year's new grantees and the research reports of the past year's grantees. As you know, our environmental situation is getting worse every year. Humankind has sacrificed its environment in exchange for its prosperity. That is the reason why we established the Blue Planet Prize. I hope the winner of this prize from Indonesia will be awarded someday again, especially from Ethiopia. I sincerely hope all of researchers here can contribute to our precious Blue Planet through your researches. Once again, I'd like to express my deepest appreciation to Professor Reni Wiradu Guzman, Professor Inde Wenton, and Dr. Cristiano Indartono, and all members concerned kindly supported the ceremony and the award ceremony as well. As closing my speech, I would like to express the points I firmly believe in for all of you today. Your future is bright. Your potential is unlimited, and your possibilities are endless. Thank you very much. Terima kasih banyak.
Ya, terima kasih banyak ya si Mamura-san. Indonesia gohana shimasu ka? Sedikit loh. Contoh nih. Okay. Arigatou gozaimashita. Hi. We would like to welcome the President of PT Asahi Chemical, Mr. Jun Miyazaki, and the General Manager of AGC, Mr. Yoshiko Sato. Well, ladies and gentlemen, we are now moving on to the Certification Awards 2022 to 14 researchers by the Asahi Glass Foundation. Shimamura-san. I will start calling the names out, and the recipient will come forward, receive the certificate, show the certificate to be photographed, and after that, please return to your seat. Okay, all right. Dr. Irwan Gumilar, STMSE from the Faculty of Earth Sciences and Technology.
Okay, 1, 2, 3. Once again, 1, 2, 3. Okay.
Please speak in 3 languages, ya, Shimamura-san. Arigatou gozaimashita. Okay, Dr. Tek Dudi Darmawan Wijaya, STMSC from the Faculty of Earth Sciences and Technology.
Okay, 1, 2, 3. Okay. Once again, 1, 2, 3. Okay.
Dr. Insinyur Eka Junarsah MT, who will be represented by Miga Magenika Julian STMT from the Faculty of Earth Sciences and Technology. Professor Dr. Andes Freddy Permanazen, MS, MSc, DSc, from the Faculty of Mathematics and Natural Sciences.
Okay, 1, 2, 3. 1, 2. Okay. Yeah.
Wibawa Hendra Saputra SSI, MSc, MSc, PhD from the Faculty of Industrial Technology.
So, 1, 2, 3. Okay, 1, 2, 3. Okay.
Dr. Eng Muhammad Iqbal, STMT from the Faculty of Industrial Technology.
Okay, 1, 2, 3. Okay. 1, 2. Okay.
Okay. Bagusnya pera-pera janai. Dwita Astari Pujiartati, STMT from the Faculty of Industrial Technology.
One, two, three. Once again, 1, 2, 3. Okay.
Lia Amelia Tresna Wulan Asri SSI MSc PhD from the Faculty of Mechanical and Aerospace Engineering.
Okay, 1, 2, 3. Okay, 1, 2, 3. Okay.
Yon Sunitioso, STM Eng PhD from School of Business and Management.
One, two, three. Okay, 1, 2, 3. Okay.
Dr. Eng Prihermawan STMT from the School of Business and Management.
One, two, three. Okay. 1, 2, 3. Okay.
Melia Famiola STPMT PhD from the School of Business Management.
Okay. 1, 2, 3. Okay, once again, 1, 2, 3. Okay.
Professor Dr. Sukrasno MS from the School of Pharmacy.
Okay, 1, 2, 3. Once again, 1, 2, 3. Okay.
Dr. Lucy Dewi Nurhayati Sasongko MSc, who will be represented by Dr. Rerna Chaturiani SSc MSc from the School of Pharmacy.
One, 2, 3. Okay. 1, 2, 3. Okay.
Faisal Imaduddin Mira Rahmat, STMT PhD from ITB Center for Water Resources Development.
One, 2, 3. Okay. 1, 2, 3. Okay.
Maybe stay. And now we would like to invite all the recipients and Pak Yuli, Pak Rino, Pak Joko. We would like to have the photo session in front of the stage. Pak Ian, boleh diatur pemotretannya?
Dua baris.
Ya, 2 baris.
Iya, 2 baris.
Saya ingin potret aja ini.
Yang di bawah.
I see. Okay.
Okay.
Prof mungkin boleh di tengah, Prof ya. Ya. Pak Wibawa boleh ke paling bawah aja boleh. Gomenasai. Oke. Boleh maskernya dibuka sebentar ya. Yang sebelah sini jangan Pak. Okay, that's right. 1, 2, 3. 1, 2, 3.
Once again. Okay.
1, 2, 3.
1, 2, 3. Okay.
Thank you so much. Ladies and gentlemen, now we are going to start the third session of this seminar on life sciences and health that will be delivered by 8 research grantees. Rindia Maharani Putri, SSC, MSc, MSc, PhD from the Faculty of Mathematics and Natural Sciences. Helen Julian STMT, PhD from the Faculty of Industrial Technology. Dr. Indra Wibowo, SSC, MSc from the School of Life Sciences and Technology. Husna Nugraha Praja, SSC, MSc, PhD from the School of Life Sciences and Technology. Dr. Magdalena Leni Situmorang, SSC, MSc from the School of Life Sciences and Technology. Ramadhani Eka Putra, SSC, MSc, PhD from the School of Life Sciences and Technology. Isa Anshori, STM, PhD from the School of Electrical Engineering and Informatics. And Professor Daryono Hadi Cahyono, that will be represented by Tasya Amelia S. Farm, MSc from the School of Pharmacy. This session will be moderated by Dr. Anindria Nastiti, STMT, from the Faculty of Civil and Environmental Engineering. Dr. Nastiti, time is yours.
Thank you. Good afternoon, ladies and gentlemen. Welcome to the afternoon session of the grant ceremony and seminar on research findings assisted by the Asahi Glass Foundation. I would like to welcome you all in this afternoon session, and especially to Dr. Takuya Shimomura from Asahi Glass Foundation, Prof. Quentin, Prof. Yuli, Prof. Joko, and Dr. Rino from LPPM ITB. Welcome to all the participants and also ladies and gentlemen in this very nice event. So my name is Anindria Nastiti from Faculty of Civil and Environmental Engineering, and I will be serving as your moderator for today. So we will have 8 research grantees that will present their findings on life science and health. So I would like to give floor to the 8 grantees. You will be given 15 minutes for each of your session and 10 minutes to present your research and 5 minutes for Q&A session. So I would like to call the first research grantee who will be presenting her research, transformation of tropical marine diatoms into light-activated catalyst for treatment of palm oil meal effluent by Rindia Maharani Putri, PhD. So please, the time is yours. 10 minutes.
Okay, thank you for the opportunities. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum.
Distinguished guests from the Asahi Glass Foundation, from ITB, my fellow presenters and awardees, and also all of the audience today. Good afternoon. So my name is Rindia. I'm from the Biochemistry Research Division. I'm just going to use this one. I'm from the Biochemistry Research Division from FMIPA, or the Faculty of Mathematics and Natural Sciences in ITB. And today I would like to tell you a little something on the marine diatom. So it's a creature that we have in the ocean of Indonesia, and how we transform these tropical marine diatoms into light activated catalysts for the treatment of palm oil meal effluent or POM. Next slide, please. Okay, so first of all, we know that Indonesia has a large ocean body in our country, and we have a lot of biodiversities in Indonesia, including also in the maritime or in the ocean. And one of the microorganisms in the ocean is microalgae. If you like to swim alongside the shores, you can see sometimes the yellow color or red color or green color or brown color. Most of them are from the microalgae. And one of the most unique microalgae is the diatoms. And diatoms are unique because they have silica shell. So normally we, like animals and human as well and other bacteria, they have lipid cells, lipid bilayer as the membrane. But this particular creature, they have silica as their shell. So we would like to make use of this. And interestingly, they also have distinct feature in their structures. So this one is that we took ourselves using HRTEM. As you can see, it's centric like that. It's like a wheel of the car. It has poros all over the surface. It has large surface area, up to 100 meters squared over gram. It's very easy to modify chemically because it's silica as IO2. So we can modify it chemically as maybe the general chemists know how to do it. And a lot of reports have been referring to these materials as a matrix for catalysis, including for photocatalysis as well. They use this for air purification, for degradation of dyes like rhodamines and other dyes. And in this presentation, I would like to present how we take it to another level, to an application that has not been reported before, which is, next slide please, to be able to use the biosilica as a matrix to immobilize the titanium-4 oxide, or as known as titania particles, as a light activated catalyst for POM degradation. So POM degradation is one of the most interesting problems and also challenging problems in Indonesia. As we all know, around 85% of the palm oil are produced either in Indonesia or in Malaysia. So it's very important to also tackle this problem as a scientist and develop the biodiversities of Indonesia to also try to solve these environmental problems. So next slide, please. Okay, so first we try to modify the shell of the diatoms. So the story is we take the diatoms from the beach, from Pulau Seribu. Maybe some of you have been there. Kepulauan Seribu. It's called the Bidadari Island or Angel Island. I'm not sure if they have translation in English. So we took the microalgae and then we bring it here to ITB and we grow it in the aquarium. So it's like if you have pet fish, but in this case we have pet microalgae in our aquarium. And then we treated them chemically. We grew them for about 2 weeks and then we treated them chemically using nitric acid. And after that, we also put them in an oven for calcination for around 500 degrees Celsius. But first, after growing them for 2 weeks, for a fortnight, we get this spectrum. Chemists would be able to read this and you can see the chemical fingerprints, for instance, the carbonyl group over here, hydroxyl group over here. They have a lot of organic contents, of course, because they're biomass. And then we treated them with nitric acid and also with calcination at 500. And of course, no organic content would be able to survive that. So they would all become CO2. And we see that this carbonyl fingerprint disappears. And we can also confirm that we get a pure biosilica. So we call it biosilica, silica from biological sources. And then we modify with titania. But as you can see, there is no change really from B to C. So this one is biosilica only, pure biosilica. And this one is biosilica modified with titania, but you cannot really see any difference. The distinguished PiOSI, the EOSE band, normally shows up at around 900, but we don't really have it here, meaning that we do not form any covalent bonds between the TI and OSI. So we cannot really confirm whether we really have the titania on top of the silica using FTIR. So we use another technique, which is the XRF. With XRF, you can really quantify the oxide of several materials. And we try to vary the percent of the titanium in the beginning, and we can really try to really push it to the maximum loading of titania, which gets about to around 58% or so. So that means we have 1-to-1 ratio between the biosilica and also the titania. And more than that, we cannot really increase the ratio anymore. So it's kind of, we have maxed out the ratio over there already. Next slide, please. Okay, and then we analyze it with the UV-Vis DRS spectra for powder. And from here, we can determine the band gap with the tall plot over here. If we have only titania, TiO2, we have the band gap of 3.41 electron volt. And normally TiO2, you will use it in your daily life as a sunscreen to block the UV light because they can absorb UV light. But in this case, we would like to use visible light, so it's possible to use solar light. So we have to decrease this band gap. And it seems that when we increase the titania loading on the silica matrix, we do have an increase of the band gap from around 3.4 to around 3.2, which is not a lot, but quite significant to make them a photocatalytic material. Next slide. Okay, now on to the most interesting part of it. You know how if you have pets and then you normally take pictures of them, like pictures of your dogs, your cats, and so on. In this case, we also take picture of the organism that we try to cultivate in our lab. This is taken by the HR10, high resolution TEM. And you can really see the size is about 3 to 5 micrometer. So it's microalgae, micro size. And then if we zoom in using the HR10, you can see the pores. So here are the pores, and zooming in onto the pores, you will see the nano-sized pores. And inside the nano-size, like 100, 200-ish pores, we can see that they also have smaller pores inside of around 5 to 10 nanometers. So they have pores inside pores, and we call this the hierarchical pores. So the structure is very interesting. And when we zoom in even further, for instance, to this part of the edge, we take it over here. We cannot really see any interesting structures. And if we take the measurement using the SAED, which is selected area electron diffraction, this is the characteristic for amorphous materials. So no organization, not crystalline materials. But once we have titanium in it, if we can go to the next slide, you can see the pores. So maybe the previous slide before, so everyone could remember these, how the pores look like as it is for the pure biosilica. And the next slide, you can see the pores still in the back, and now the titania particles sitting atop of it, of the biosilica surface. And if we zooming it into several particles, we can see quite irregular shapes. There are some circles, or distorted oval shapes like this of around 15 to 30 nanometers. And of course, this is from the silica. And we take a look at the crystallization properties. So before it was amorphous, so no organizations. Now you see the polycrystalline. I hope you can see it from afar. You see the patterns of the polycrystals. So now we have crystals, titania on top of our biosilica. And we take the XRD spectra over here. If we have only a small amount of titania, you cannot really see the crystalline. So the peaks normally indicate that you have a crystalline materials, in general. And you can see that with little titania, it's not really you cannot really see it clearly. But when you increase the titanium proportion, you will get crystalline materials. And from the crystal planes, we can conclude that this is an anatase phase. It's a phase for titanium, which is not as stable as the other phases, like the rutile phase. But this anatase,
your time is 1 minute left.
Okay. The anatase phase is one of the most photocatalytically materials. So on to the next one. So we done the degradation of the POMI using the system, and we can get up to 50% of degradation of the POMI using the system, and they follow a first order kinetic. Maybe I can go to conclusion now. I hope I have convinced you that we can use biosilica from Indonesian Ocean and then immobilize it with titania, where they are trapped in anatase phase, which lower their band gaps, and they can be used to degrade the POM from local plantation in Indonesia. And finally, I would like to thank my student and also my collaborator, Dr. Hendra, which is also in the audience, and all of you for your kind attention. Thank you.
I think that was very interesting presentation, Dr. India. So I would like to open the floor for questions. We have 5 minutes. Perhaps distinguished guests from Asahi Glass Foundation would like to ask the question first.
Thank you for the presentation.
Thank you very much.
You mentioned the microsilica from the biomaterial bioatom is very large surface area. It's a merit for the to contain a lot of titanium oxide.
Exactly.
On the other hand, we have some concern about mechanical strength. How about this one?
Yeah, it will differ from one species to a different species. In our case, we use the one that is called Cyclotella striata. In that case, it depends on what kind of mechanical agitation you give into the materials. If it's from vertical, like if you use AFM and press it from the top, it would be quite strong. But if it's from the side, because it's glass, so silica is glass base, so you can also actually break it. But nevertheless, you would still have the porous surface, and they would still have around 100 meters squared over gram surface area, all in all. Thank you.
Okay, thank you. The audience, perhaps would you like to have a question for Dr. India? Oh yes, please.
Thank you for your nice presentation. And could you explain to us how to evaluate the decomposition of POME applying various kinds of catalysts? So I'm not sure that the order of the activity relates to the titanium weight or surface area or something.
Yes, thank you. It's a very interesting question because we also have this, we wonder about this as well. So from the photocatalytic activity, we check from the chemical oxygen demand from the POM, and then we see it decreases. In general, they would decrease more when we have more titanium content, but indeed we have like one samples that is quite the outlier, so we would have to check that again. Only the one that we try to really push to a higher content, maybe we can go back to, yeah, I'm gonna. So the outlier would be this one. And it could also be from degradation because we really try to, from aggregation, sorry, because we really try to put a lot of the titania, but from our analysis, it doesn't seem that all of them are immobilizing the surface, and probably that also has effect to the photocatalytic deviation that we got for this particular composition. But we will have a look into that. Thank you.
Thank you. We still have time for one more question for Dr. India. Okay, anyone, please? Okay, if not, then probably thank you so much, Dr. India. That was really innovative for towards the good environmental management and also pollution in Indonesia. So I hope that you will be successful in your next endeavor. Thank you so much. Thank you. Next, I would like to call Helen Julian, PhD. With the title of the presentation would be the concentration of seawater reverse osmosis brine by membrane distillation for chloralkali plant feed solution. Thank you. The time is yours. Okay. Good afternoon, honorable guests, ladies and gentlemen. Thank you for the opportunity given to me to present our research finding on the research funded by Asahi Glass Foundation. Thank you. The title of the research is the concentration of seawater reverse osmosis brine by membrane distillation for chloralkali plant feed solution. So the chloralkali plant is the place that we can process brine to produce caustic soda, hydrogen gas, and chlorine gas. The feed for this process is near saturated NaCl brine. So we need to use high purity sodium chloride brine with concentration to up to maybe around 31% weight as the feed for this process. Common procedure to provide feed is by dissolving high-grade industrial salt into high-quality water. However, the process to produce high-quality water and high-grade industrial salts is also already energy-consuming. On the other hand, we have this. This is desalination plant. The desalination plant is the place where we can produce fresh water from the seawater. In order to produce the fresh water, of course, the desalination plant needs also to produce what we call as reject brine. Reject brine is basically the waste of the desalination plant. So the reject brine has the concentration of salts at around 60 to 70 grams per liter. This number is quite high, actually, especially when compared to the seawater concentration itself. So combining these problems, so the CAP has the problem of providing feed, and the brine, the desalination plant has the problem of disposing the brine. We propose the utilization of seawater reverse osmosis brine as the CAP feed. However, the seawater reverse osmosis brine cannot be directly used as a CAP feed. It has to go through some stages of pretreatment and concentration. So as the brine composition is not only consists of sodium chloride, but also consists of other kind of salts in the seawater, we need to pretreat the brine first. So in this research, we will use nanofiltration as the pretreatment stage for the brine. And after the pretreatment stage is complete, we will concentrate the brine by using membrane distillation. So we need to remember that the brine concentration is only 70 grams per liter top, but we need around 300 grams per liter of brine concentration for the CAP feed. So we need to pre-treat and we need to concentrate. So I believe everyone already know what is nanofiltration membrane, but I want to highlight what is membrane distillation because this is maybe new for a lot of people. So membrane distillation is basically a porous hydrophobic membrane, as we can see here. The white one is the membrane and the gray one is the porous of the membrane, the pores of the membrane. And this membrane, this hydrophobic membrane separates two solutions. Here we have hot brine solution and here we have cold pure water solution. So because we have different temperature here, we can generate
vapor pressure gradient. The vapor pressure on the feed solution on the brine will be higher than those on the permeate solution. So the vapor from the feed will transport past to the pores to the permeate solution. Over time, the feed here, the brine here will be more and more concentrated. In this research, we want to evaluate the robustness of the membrane distillation in concentrating salt solution. So we varied the feed that is being processed by membrane distillation. First, we use just pure sodium chloride. And second, we use a sodium chloride complex, which we have calcium chloride and sodium bicarbonate there. And also the last, we use model brine solution, which consists of complex salts, like 5 kinds of salts. And also to evaluate the performance of the membrane, we also varied the feed temperature at 50 and 70, and also this is supposed to be permeate flow rate at 0.44 and 0.88 meter per second. Okay. The membrane distillation actually faced two major problems in the operational site. So the first one is the fouling deposition. Fouling is basically just like unwanted material deposited on the membrane surface. If you have excessive fouling, then the fouling will block the membrane pores and reduce the mass transfer. And the second problem is the wetting. Wetting means that the membrane lost its hydrophobicity. When that happens, the membrane can pass everything, not just water vapor. It can pass the feed solution in the liquid form. And what happens if the membrane pass the liquid feed solution? The membrane will have very poor separating performance. Means that the feed and the salts also can pass and move to the permeate site. Yeah, means that the feed here cannot be concentrated. Okay, so now let's move to the results. This is the results from the pre-treatment stage. Here we use Sutsutorai membrane nanofiltration, and we can see here that this membrane can reject divalent ions really well. The blue one is for calcium and the gray one is for magnesium. The rejection for the magnesium is around 65% and the rejection for the calcium is around 60%. Meanwhile, for the monovalent ions, here we take sodium, the rejection is quite low, is less than 10%. So this is good for our purpose because it can reject the impurities but maintain the sodium that we need for the CAP plant. And this is the effect of operating condition on the MD performance, on membrane distillation performance. Here we varied the feed and the permeate flow rate. For the flux itself, we can see that if we operate the membrane at higher temperature, 70 degrees Celsius, the flux is higher. Means that we have a lot of water vapor pass through the membrane pores. Means, in other words, we also have faster concentration of the brine. Meanwhile, the permeate flow rate itself didn't really show significant effect. So the feed temperature affecting the performance more. The most interesting part is here. Here we have a permeate conductivity data. Permeate conductivity represents like how much salt present in the permeate site. If we have salt in our permeate, means that we have wetting and means that our process is failed. Okay, so basically we don't want to have salt. If we have just like a bit of salt, this is okay. Yeah. So basically the water that we drink, the permeate conductivity of the water that we drink is usually around 200, 300 microsiemens per centimeter around here. Okay. So this is interesting because the permeate conductivity data shows us that the experiment conducted at 70 degrees Celsius and permeate flow rate 0.44 meter per second shows really not really severe wetting. This is a very good one. Means that the performance of the distillation still can be maintained up to 50 hours of operation. And during these 50 hours of operation, we can concentrate the brine to up to 280 grams per liter. Oh, sorry, this is not the brine. apologize. This is the nanofiltration permeate. So this is the brine that already been pre-treated. Yeah, so the final concentration can be reached is 280 grams per liter. This is quite good, quite high, but we need also to still consider that in here, this is not pure sodium chloride. We still have impurities, but in a very low concentration. Still need another purification stage after this. And this is the result when we want to evaluate the effect of feed composition on the MD performance. In here, we want to check the robustness of MD in treating like maybe very challenging with water. If we use just the brine, the desalination brine directly, we can see that the flux drop very quickly. It means that the membrane already have like severe fouling, no more water vapor can pass through the membrane pores. And also we can see that the wetting occurs very quickly. Means that we have no vapor, and even though we have a bit of vapor, it's already contaminated by the salts. It's not good. Yes. Thank you. Okay. And if we use sodium chloride, just sodium chloride here, the flux is okay, but still we have wetting. But if we use the nanofiltration permeate, the flux drop a bit after 50 hours, but the quality is very good. So this is important because this highlights the importance of pre-treatment, a good pre-treatment stage before concentration stage. And this is the SEM image. This is the pristine membrane, the very clean membrane that never been used, very clean, pores clearly visible. And this is the membrane that's already been used to treat the nanofiltration permeate. This is still very clear, indicate no really, we cannot see really wetting or fouling here. But for the membrane used for the sodium chloride and sodium chloride complex solution, fouling already occurred and wetting already occurred as well. And this is the DDS spectra to evaluate the crystals composition. We can see sodium base and calcium and magnesium base crystals there. Okay, so that's all for the presentation. Due to the limited slide number, this is my last slide. Thank you.
Thank you so much for a very interesting presentation on this very important topic, because water is something that is really a pressure problem, I think, in Indonesia. So I would like to open the floor for questions, probably, sir.
Thank you for the presentation. You showed the selectivity of the membrane, calcium, magnesium, and the sodium. Yes.
This one?
Yes. Direction of calcium might be the 60%, magnesium also. This quality is sufficient for ion exchange.
So yes. So basically, usually in the use of brine for CAB feed, we need 3 stages. The first one is pre-treatment, that is usually being used by being conducted by nanofiltration. After that, concentration. Usually concentration they use multiple evaporator, but here we use under distillation. And usually we need to have another one, which is purification. So at the purification step, we already have concentrated brine, very concentrated brine, which is lower in volume compared to the initial brine. So in the last stage there, in the purification stage, usually we have ion exchange to remove the remaining impurities, which is not really much. Yeah. So yes, that's why I say even though the concentration is quite high, the concentration is 280, still have impurities that need to be further purified, maybe by ion exchange.
Okay, thank you.
All right, thank you. Anyone else have questions for Dr. Helget? Well, then perhaps I would like to ask, because this desalination is something that we hope to be an alternative source for water in Indonesia. What do you, because I'm not from a really engineering background, but I would like to know the application for the upscaling of such an innovative technology on a larger scale. What do you think about that?
Okay, so basically for the membrane distillation itself, a lot of experiment already conducted, a lot of research, and it already been in the pilot scale. But the main purpose of membrane distillation is actually for desalination. Means that you have seawater, put it in membrane distillation, and then you get fresh water. But you can get a lot more fresh water than reverse osmosis because it can work in high concentration, more higher than the reverse osmosis. Yeah. But yeah, it's just under the pilot scale until now, but not in Indonesia. They have it a lot in Spain. Very rigorous research on this in Spain.
Yes, thank you. I hope that we see a lot of these in Indonesia because we have potential for this application, but very limited scale at the moment, only on pilot, right?
Yes.
Okay, thank you. Any question again for Dr. Helen? Yes, please.
Interesting presentation. I want to know how to avoid falling.
Actually, there are a lot of things we can use to avoid falling. We can use physical method. For example, we can do like scoring on the surface by using either air bubble or the methods of compression or things like that. And we can also do optimization on the process control of on the operation condition. We can choose a certain temperature and certain flow rate that can minimize the flow rate. And if nothing can work anymore, we can just do the cleaning of the membrane. Yeah, so basically falling in membrane cannot be avoided, but naturally happen.
Okay, any question from the guests? Well, if not, then I would like to thank you, Dr. Helen Julian, for a very interesting presentation. Now moving on to our third speaker, I would like to call Dr. Indra Wibowo from SITH, School of Life Science. His presentation will be micronose analysis in gonadal maturity regulation of male Niletia tilapia in response to carica papaya seeds extract exposure. Please, the time is yours.
So, good afternoon, everyone. Thank you very much for coming to the grand ceremony and seminar on the research findings and held by LPPM and Asahi Glass Foundation. And to begin with, I would like to thank to my research partner first, to Dr. Anggraini Bardian. She's a senior scientist in our school, and she's been doing much research on the carica papaya and also in fish with me. And then Dr. Husna Nugra Praja, who is doing bioinformatics, and our research assistant Roya Zubasen. So, and to begin this presentation, I would like to talk about my research, one of my research, on how gonad maturation influenced by aging certain compounds, which is in this case is carica papaya seed powder, and how this exposure to carica papaya seed powder can affect the maturation of gonad, and at the end can change the microRNA profile in the gonad. So I would like to explain later what is actually microRNA. So according to the World Organization, tilapias are a group of water fish species and the second largest of the global aquaculture production of pterocarps. And tilapia are farmed in more than 100 nations, and primarily tropical and subtropical parts of Asia, for example here, okay, and also in Southeast Asia, America, and also in Africa. And in a variety system and environments, they already have a really good production of these tilapias. And the production in 2018 approaches 6 million tons worldwide. And then the main producer countries are China, okay, Indonesia, and Egypt. However, the presence of the female tilapia in the grow out phase is undesired, okay, and that's why usually that female become reproducing as early as 6 months after hatching. That usually it's too early for production of the tilapia, and thus they can divert their food energy from growth to reproduction. So instead of growing in a bigger mass, then they will reproduce a lot of progenies. But in uncontrolled reproduction, typically in the ponds, result in excessive recruitment of fingerlings. So that competition for food and stunting of the fish become shortened of the original stock, and which result in harvest containing fish with a wide variety of sizes and also weight. So in short, in regards of tilapia, females are problems, okay? So female is not always right, okay? In this case, females are problems. The main source of the economic interest of most commercial tilapia producers, several methods have been developed. And the production of all meal or mono-sex tilapia fingerlings, for example, have been interesting for farmers. Two methods have been developed, for example, hybridization. So you can crossing the different species of tilapias to get more males than females, for example. And also what you can do is the sex reversal. Okay, so what is interesting in fish is that, or several vertebrates, lower vertebrates, they can make a sex reversal, and this is become advantage for the fish itself, or also for farmers. And sex reversal actually means converts for genotypic females into phenotypic males. So this is what we have before, that papaya seed meals are actually suppressing the reproduction of male tilapia, and they can grow the body even bigger. And this alteration of reproduction is believed can give feedback for the body weight through the energy flow mechanisms, so that we can get bigger fish. However, according to our previous study, although carica papaya meal can suppress the rate of reproduction with increasing body weight, the treatment with carica papaya in this point suggests that we can help sex reversal in this point, okay? So that the carica papaya seed powder can be used. Sex reversal actually also can be used with the hormone, for example, methyl testosterone, but then it will contaminate the environments that we don't like that to happen. That's why the natural alternative is using carica papaya. But why is it very important? Because actually they can make the fish bigger, and the reproduction is lower. And this is probably because of the gonadal maturation effect on the gonadal maturation. And some research have been found that there is a certain or specific microRNAs in the body of the fish that can regulate gonadal maturation, especially in male tilapia. So what is actually microRNAs? MicroRNAs is a microRNA, small non-coding RNA molecules that can be found in our body, in the body of organisms, and they can target more than one mRNAs that is influencing multiple molecular pathway, but also this mRNA may be bind to a variety of microRNAs. So, and then what happens next is that this microRNA can inhibit the transcription or translation, or even can change the epigenetics of genome. So the main function is actually to down-regulate gene expression in variety of manners, including translation, repression, mRNA cleavage, and also involved in the differentiation, proliferation, apoptosis development in both health and disease. So that's why we are designing our experiments using Nile tilapia, and we have two groups with no carica papaya powder or spider fat, and also we use papaya powder 2 grams per kilogram of body weight, and we will see the growth and also gonadal maturation. For the growth, we will have examine the growth performance parameters and feeding efficiency. For the gonadal maturation, we'll have histopathological analysis, and also using new technology, microRNA sequencing analysis. So from our result, we saw that the specific growth rate, feed conversion ratio, and condition factor of Nile tilapia after being fed with modified diet are higher than those fed with normal standard diet, as seen in this table. Okay, so we have here no treatment and with treatments. And then we also comparing the body weights of tilapia from non-treatment group, which is we give them basal diet fat, and the treatment groups with the modified diet fat, and you see that the body weight are really high. And our last results actually is based on this histopathological comparison of male gonads. You'll see here that there are a lot of sperms, yeah, spermatozoa in the gonad of the males instead of in male gonads. Okay, so we will still have to do the further analysis and counting which what is the difference, significant difference between male gonad in control and the one with the papaya powder fat.
Dr. Indra, please, your time is 1 minute left.
Okay, so at the end, because this experiment really challenging, then we don't get yet the mRNA sequence of the gonads, but we have already the raw materials that haven't been analyzed, and we'll do something like this later on to see which microRNAs are expressed or upregulated or downregulated later, and then we can do something like treatment for the fish, and we can get a bigger fish with treatment with microRNAs. So the concluding remarks actually is that the best of our knowledge, this is the first experiment to determine the efficiency of carica papaya to tilapia gonadal maturations, and hopefully this finding of the study will contribute scientifically as well as provide information to improve fisheries. Thank you very much.
Thank you, Dr. Indra, for your very interesting presentation. I would like to call the audience for questions. Perhaps distinguished guests, yes?
Okay.
Yeah, thank you very much. You mentioned the 6
reversals.
Yes.
Yeah.
I think that phenomenon occurred. Some difference between the before the and after. Some difference.
Differentiation. Some differentiation.
Micro RNA.
Yes, microRNA.
Some difference.
Yes, actually, in is another studies that they have differences microRNAs in differentiate. Sorry. Here, In the larva stage and the on-growing stage, they have quite different microRNA species. So that's why probably because in larva stage, they are still developing, and then a lot of microRNA is regulating the genes that are used for growing the fish.
Thank you. Another question, please. Yes, please, sir.
Which period you throw the 2% bioseed, including feed?
Yeah.
The on rather stage or on growing?
On growing, fingerlings to on growing to broster.
Okay.
Yeah.
So the sexual conversion to male fish. The fish when can you detect the exchange in the during in the growing?
Growing. Okay. So I didn't show you the female gonads. The female gonad. We have actually the female gonads in this stage as well, and we see that there is a abnormality in the female gonads. That probably there is a direction to the male gonads, but we need to check first what these phenotypes. Because I think it's not enough time because we only have like 1 month of treatment.
All right, thank you. Another question? No, perhaps I'm interested about the things that you said in the end, that this is environmental friendly options for feeding and fish. So because in Indonesia, especially in West Java, I think feed from fish industry is one of the cause of environmental pollutants. So what's your take on this issue? Is there any potential application for upscaling this environmental friendly option?
Okay, thank you very much. So the sex reversal, actually, you can, as I mentioned before, you can use hormones, for example, methyl testosterone. But then you don't want the effect of the testosterone influencing a fish, right? So that's why with this calico papaya seed powder, probably you can use it as the natural and environmentally friendly materials. And I don't know whether we can use it in a larger scale, but we can try. This is only a laboratory scale, but yes, although there is an anti-nutrition actually in the calico papaya seed powder, means that the fish, if you give them more time of the calico papaya seed powder, they will actually decreasing the body weight because this anti-nutrition. So we need to check first in a large scale.
Okay, thank you. I think we are looking forward for a wider application for this. Yes, thank you, Dr. Indra, for your excellent presentation. Okay, the fourth speaker would be Husna Nugra Praharja, PhD, on response on microbial community structure and dynamics of black soldier fly organic waste treatment using omics technology approach. Okay, the time is yours.
Okay, good afternoon, distinguished guests from the Asahi Glass Foundation and also the chair of the Institute for Community for Research and Community Services, Yuli, and also ladies and gentlemen, thank you for coming in this seminar. So I'm going to talk about the response of microbial community structures and dynamics of black soldier fly organic waste treatment using omics technology approach. And I come from the School of Life Sciences and Technology. Okay, let's talk first about
waste that we know most of the waste are come from the food, and as you know, even in Indonesia, is like million of tons coming from food waste, and today is still very quite a big problem. And fortunately, nowadays we have an alternative how to organize the waste using the black soda fly. Actually, this is introduced, and we can use the larva, especially to make some composting. The output of composting from the larva of black soda fly, it can be solid waste, solid waste, or the lichet, or we call it the lindi. And if you see that the period of the composting process, as you can see, is already studied by the other researcher here. And what actually the idea is how to see the microbial community structures. What we want to see is the bacteria community structures and also the fungi bacteria structure using the diversity marker. First, we use the 16S rRNA, and also the second one for the fungi, we use the ITS. This is what you see is the molecular structures of the gene from the 16S and also the ITS. So what actually we did here, we take the sample and we did the DNA extractions, make the library preparations until the next generation's data analysis, and we come up to downstream analysis. So the aims of this research is to determine the profile and the abundance of microbes contained in solid food waste and linear water coming from the treatment of BASF larvae using the metagenomic study approach, especially 16S for bacteria characterizations and the ITS for fungi. This is just to give you the framework how we analyze. So we have the solid waste coming from the organic food, from the household, and then we use the larva and we make a compost. We have the output, the product is the food and also the water, the linear water. And then we try to extract the bacteria and using the next generation sequencing. Here we use the Illumina. We try to check the data and the microbial community structure using this pipeline analysis. And we come up to the discussion. So at the time, as you can see, this is what we call the rarefaction curve. The rarefaction curve, especially we can see the exponential curve until the stationary curve. And here we can see that our sample is coming to the stationary curve conditions. Means that our microbial community structures can be captured using the next generation sequencing. But however, as you can see here, using the diversity community analysis, there is no significance using the statistic between the solid and also the linear water here. So this solid, this is padat and also cair. Padat means solid and cair, the linear water here. There is no significance, but also we can see based on the diversity, there is no differences between the diversity of microbial coming from the bacteria or the fungi. If we compare the output product from the BASF treatment, from the water, also from the solid product. And this is what we see, that the ITS rarefaction curve is shows the stationary condition here, showing that we capturing enough to show what is there and what kind of microbes are coming from that product output of the BASF treatment. So as you can see here, this is the compositions from the 16S RNA and also the ITS. 16S again for bacteria and ITS is for fungi. And as you can see in the water, for the lily water, we can see that the Pseudomonas, the genus of Pseudomonas, has a highest proportions in the microbial community. Whilst for in the solid, the Rhodophyllella is highest proportions in the microbial community structures. If we compare with the genus compositions, here as you can see, this Aspergillus is the most predominant genus in the lily water and also the solid water. And as you can see also that this is the based on the relative abundance. As you can see, we can try to see between the Rhodophyllella and also the Pseudomonas. They are coming from the different clade of the evolutionary or from the relative abundance in the output product of the treatment. And here also, as you can see, for the ITS phylogenetic tree, as you can see, we can try to see there are some species candidate that coming from the genus of Aspergillus. We try to highlight some species is coming from the Aspergillus candidus and also Aspergillus fumigatus that also mentioned by other researchers are also predominant as the microbial in the composting system process. So the conclusions is that by using the metagenomic sequencing approach, allow us to describe the bacterial and fungi community structures and dynamic coming from the black soldier waste treatments. And that is Pseudomonas species from the genus of Pseudomonas species and also Aspergillus species as predominant microbes. And we try to extend our research or the future direction is we want to see how the larva of black soldier fly also can degrade the components. So we also are now working to see the gut microbiome of the black soldier larva. Okay, I think that's all. Thank you very much.
Thank you, Dr. Krishna, for your very interesting presentation on the application to this is like food waste, right? Okay, thank you. And from the audience, perhaps Sensei would like to have a question.
Thank you for the presentation. You analyzed the sequence of each species. And I'd like to know how long does it take for each analysis?
Okay, thank you for your questions. Actually, for 16S, is since is quite a small portion, is only 400 base pairs. We can analyze actually in one day. But how we interpret the data, that's take a long time actually, because we need to read more literatures regarding of that. But actually, since we establish, we have the bioinformatics working group here. So for the analysis, especially for 16S and ITS, actually it's only we only did it in one day.
Okay, thank you. Any questions? Oh yes.
Thank you very much for your interesting presentation, Dr. Krishna. Or maybe should I call you Senpai because you're from the same dormitory. Okay, so he's my Senpai. Okay, so I have a question, but maybe it's a little bit of a stretch. From what I know, BASF can also produce oil, right? And somewhat it can also be used for energy supply. So what do you think about the future of humankind using energy from biomass or biofuel, something like that?
Thank you. Okay, it's a very hard question because it's not my field. But anyway, when we talk about the biomass for energy, we need to think about, I think the first thing we need to think about the energy efficiency. I mean, that's, well, you can compare, for example, if you have 1 acre for the sunflower oil for production and also 1 acre for the BSF soldier fly larva. And well, I think from the engineering, you can make some calculations because I don't really understand about that. But I think the critical point in biomass conversions, especially for the energy, is the energy efficiency. So we need to think carefully because probably then we need to decide whether we need to go or not to go with this technology. Thank you.
Okay, thank you. Any last question? Yes.
Thank you very much, Musna, for your presentations. I would like to ask about why you choose black soldiers for generating the biomass compared with other species such as maggots or maybe for or other caterpillars or larvae or something.
Okay. Yeah. Well, actually, the term of maggots also is it's the same with the BSF larva. But I think the people, especially from the society, know it as maggot. Well, actually, in School of Life Sciences and Technology, I think it has a long roadmap with the BSF research. Here also there is Parama that will be present after me, but I don't know if it's the same topic or no. So actually, the research on the BSF is already has a long way and still going in our faculty. And what the idea in this project is actually I want to extend it to the molecular. Because the molecular system, especially in the BSF, not yet described. We need to detailing, especially because there are some issues also that come in. For example, that maggot that become feed for the animals. There are some issues like health issues for the animals and all something like that because the maggot eat from the food waste. So also that's why we need also to know in the molecular terms, also in the microbial community structures, whether is the BSF larva make the garbage in and also the garbage out. If we give the larva with the waste, probably we need to think if the output of the rock also the waste. Mean waste is there are pathogens that are coming from the output of the BSF larva treatment. So there are many interesting issues. Then I want to address this in the molecular field, so we can have some very nice information, especially for the microbial community structures. Thank you.
Okay, thank you. Since we are running out of time, I would like to thank Dr. Kusna for a very presentation. Organic waste treatment is probably in your head. Okay, for the next presenter, I would like to call Dr. Magdalena Lenis Situmorang. With the presentation, symbiotic modulation of gut microbiome, metabolic function, and metabolic profiles in Pacific white shrimp, Pistocanus panamigro culture in biofloc production system. Please, the time is yours.
Good afternoon, honorary guests, colleagues, ladies and gentlemen. Today, my name is Magdalena Lenis Situmorang from the School of Life Sciences and Technology, and I am glad to stand here today to share the results of our study titled Symbiotic Modulation of Gut Microbiome, Metabolic Function and Metabolic Profile in Pacific white leg shrimp, Lithopenalus phoname throughout culture in the biofloc production system. Now, the FAO recently reported that over 55% of the shrimp consumed worldwide came from aquaculture industry, so from the farming activity. With the Lithopenalus phoname, or we often call phoname shrimp, as the main species used in the shrimp industry. It takes up to 65% of the global shrimp production. However, nevertheless, the high loss in the shrimp industry is still very high, and it's mainly due to the high mortality caused by pathogenic bacteria and or virus. And this infectious diseases is mainly correlated with the low or the lack water quality management, as well as the low biosecurity, especially in an open system. Now, it is proof that once established, as infectious diseases is very difficult to be fully eradicated. That is why many believe in a more preventive approach rather than in a curative approach. That is why also in the past decade, many researchers, they are developing alternative strategies in controlling the infectious diseases. And our aquaculture team at SITH ITB, we have developed a few technologies as the biocontrol agents. The first one is to develop the closed aquaculture system. For example, the use of biofloc technology. It is to create a stable culture water quality during the shrimp production period. The second technology that we have developed over time is the development of functional feed with supplementation of prebiotics, probiotics, and also the last one is symbiotics, which is a mixture of probiotics and prebiotics. However, our team had not tested both these technology altogether. So in this experiment, in this study, the aim was to test these two technologies all together. Okay, so this study was done as a two-factor experiment. The first factor is the type of culture system, and the second factor is the type of feed. Now, in terms of culture system, in this experiment, we tested biofloc system compared to the open semi-batch system. So that's for information, the controlled semi-batch system, we rely on daily water renewal so that we can maintain the culture water quality. However, in the biofloc system, we added functional microbes that have roles in nutrient cycle so that we do not have to rely on daily water renewal to maintain the culture water quality. In terms of the type of feed, in this experiment, we tested symbiotic feed, which was produced by mixing commercial feed with functional microbes, including prebiotic in the form of red seaweed powder. We also added probiotic Halomonas alkalifila, and also we added spirulina from the cyanobacteria group at this certain concentration. So after 40 days of culture using this different type of culture system and feed, we then evaluate the shrimp growth and also survival. And we also evaluate the microbial community analysis in the culture water, and we sample the shrimp gut and see if there's any differences in the shrimp gut microbiome. Okay, so there's a total of 4 treatment groups tested. The first 2 groups, namely CK and CS, were grown in the controlled semi-batch system. The CK was fed with commercial feed and CS fed with symbiotic feed. The other 2 treatment controls were grown in the biofloc system, namely the BK and BS. The BK was fed with commercial feed, while the BS was fed with symbiotic feed. Okay, so after 42 days of culture period, we saw that morphologically we did not observe any differences morphologically in the shrimp. So you can see they look particularly safe. However, if we look on the culture performance, first I would like to see the growth parameters. There was no significant differences in the shrimp growth among these 4 culture treatments, even though we saw the highest growth. So this is the mean body weight and also average daily weight gain. The VS resulted in the highest growth, even though it was not significant. However, when we see the survival rate, so the survival of the shrimp and also the total biomass, we observed that the biofloc treatment groups resulted in the highest performance, specifically in this BS group. So the one grown in the biofloc system and fed with the symbiotic feed. Now, interestingly, we found that lower number of Vibrio was shown in the biofloc treatment groups. And this is especially in the BS group. And this indicates that the functional microbes that we add into the culture system may suppress the growth of Vibrio. And this is also the same microbial observation was also shown or observed when we look onto the microbial community in the shrimp gut. Again, we saw that lower number of Vibrio was shown in the biofloc treatment groups, whether it's fed with commercial diet or symbiotic diet. So again, this is the second indicator then that our functional microbes added into the culture system, either through the culture water or through the symbiotic feed, they can suppress the Vibrio growth, possibly due to competition of these functional microbes with the Vibrio in terms of nutrients, in terms of space, and also our functional microbes might also provide active compounds that might act as direct antimicrobial activity. Also, there's a hypothesis about the Vibrio quorum sensing disruption phenomena by our microbial functional microbes. Also, the next result is that when we use different culture system and also different feed, we also observe that the shrimp gut microbiome functional profile was also different. And this is indicated by this PCA graph, where each treatment group is located at different quadrant. And through the PCA analysis, we know that the symbiotic feed is positively correlated with the utilization of amino acid